Hey everyone, and welcome to Spark September. This is the first video in a series of 30 whereby we'll be learning Apache Spark in 30 days within Microsoft Fabric. And so if you're not familiar, the data engineering and data science experiences within Microsoft Fabric are based on Apache Spark. So if we want to become really good in Microsoft Fabric, then we need to have a really good understanding of Apache Spark, what it is, how it works, how to use it, how it integrates into Fabric, and how you can get the most out of it to perform your data transformation, data science, data engineering tasks. So over the next 30 days, I'm going to be walking you through a variety of different situations. We're going to be starting off at a high level. So this course is really built for people that are new to Apache Spark. If you're a seasoned data engineer, it might just be a bit of revision for you. But we'll be starting off with a bit of a welcome today. Then we'll be moving into why Spark? Why is this so important? Why do we need to learn this? And why is it in Microsoft Fabric in the first place? Then we'll be walking through the different elements of Spark. Specifically, we'll be focusing on the DataFrame, and we'll be learning how to do common operations with DataFrames, like reading files, interacting with a Lakehouse, writing tables to a Lakehouse, for example. Then we'll be going through a lot of data engineering and data transformation kind of mini tutorials in days 9, 10, 11. How do we do filtering? How do we do group bys, missing values? How do we join and merge data frames? Then we'll be going into slightly more advanced things like time series analysis. We'll be looking at Spark SQL. Then we'll be looking into the MLlib functionality, which is the inbuilt machine learning library, machine learning kind of framework built into Spark. So we'll be learning about feature engineering and doing machine learning models and evaluating those models within Spark. Then towards the second half of September, the last 15 days, we're going to be focusing more on, okay, how does this integrate into Fabric? So we'll be looking at the runtime, the Fabric runtime, which is powered by Apache Spark. We'll be looking at Spark Compute in Fabric, how to set up custom Spark pools, Spark job definitions, managing our Spark capacities, how do we manage different libraries within Fabric on our Spark nodes. Then I'll be doing a couple of videos using Scala, because obviously in Spark, okay, we can use Python, but we can also use Scala and R, and we'll be looking at the differences there. And then towards the end of the month, we'll be looking at the even more advanced scenarios like managing concurrency. How do we autotune Spark configurations using MSSparkUtils, monitoring our Spark applications and our Spark runs. And then finally, we'll be answering any questions. So throughout this course, if you have any questions, make sure to leave them in the comments, and I'll be addressing them on the route. But then at the end of September, I'm going to be going through the frequently asked questions just to make sure that all of those are answered and all your comments and queries have answers. And finally, I'll be showing you how to continue your Spark learning journey. So signposting lots of other methods that you can use to learn Spark. And we'll be doing this all within Microsoft Fabric, all within Fabric notebooks, and I can't wait to get going. Hey everyone, and welcome to day 2 of this Learn Spark in Microsoft Fabric series. Today, we're going to be focusing on why Spark. We're going to be looking at 3 things in particular. Why does Spark even exist? What problem does it solve? Why are we going through this hassle of learning Spark when we've already learned Python, we've already learned R? Why do we need to learn Spark as well? Then we're going to be looking at why have Microsoft embedded Spark within 2 of the most important parts of Microsoft Fabric, the data engineering experience and the data science experience. So why have Microsoft put this open source technology right at the heart of their new solution? Finally, we're going to be looking at when should we use Spark in Fabric? We have lots of tools available to us within Microsoft Fabric. When should we be using the Spark and the notebooks and this kind of thing? So what kind of scenarios would you expect to use Spark? I think this is a really important piece of kind of groundwork that we all need to do together, just to understand, okay, why do we need to use Spark? And I just want to start with a couple of bits of housekeeping. So thank you very much for your comments on the first video in this series. Shout out to Amrita, who's looking forward to following along, as is Lissa also. So love reading your comments. If you have any questions as we go through the course, then leave them in the comments and I'll be sure to reply to all of them. The other thing is that I've created a playlist. So currently there's only one video in there. But as we go through this series, I'm going to be adding each video into this playlist. And you can get to that either from the channel homepage. If you just go to channel and playlists, then we've got this one here, Learn Apache Spark in Fabric. So that's a really good way of watching all the videos from start to finish. And the final point that I want to make is that all of the notebooks that we're going to be going through in this series, I'm going to be putting them all on GitHub so you can follow along. In this notebook, there's no code. We're just doing the kind of markdown. We're going to be using it to just follow through some of the topics. But in future, there'll be code examples for a lot of the tutorials that I'm going to be giving. So to find that, it's github.com/learn Microsoft Fabric. And again, I'll leave a link in the description. Let's get into day 2. Why Spark? So first, why does Spark even exist? Well, in essence, Spark exists to manage and clean and transform and analyze and predict on big data sets. So we're not talking kind of a million rows, we're talking billions of rows, we're talking gigabytes and terabytes and petabytes. The whole point of Spark is that it's scalable. And the way that it works under the hood is, well, instead of having one really big computer with lots of processing power, the whole idea behind Spark is to distribute that computation power across lots of different computers, basically. So the way that it works is if you have a really big data set, it will split that data set up into various parts, and it will store each part on a separate server, basically. And it stores it in memory. So in memory, when we store data in memory, it means that it can be accessed very quickly, and we can do calculations on it very quickly. So all of these kind of distributed servers are managed by kind of a cluster manager. And when we write code in Spark, the cluster manager and Spark under the hood, it analyzes our code, it looks at what we want to do, it creates a kind of list of tasks, and it says, okay, I need to get this, I need to perform this computation on these partitions of data. And then it's going to return the results back into us in our Fabric notebook in this example. And it will say, here you go, here's your data frame. And the reason why this is so much quicker on big data is that it can do this in parallel. So you might have 100 tasks in your kind of computation scheduler. And so when you're splitting your data up in like 100 pieces, it can do these computations on all 100 pieces in parallel and then return the results up to 100 times faster in that example. So that's why Spark exists. That's what it does really well. It's been around for a while now, and it's become basically the #1 platform for big data. It's used by 80% of the Fortune 500 companies. And so it's a really kind of well matured piece of software at the moment. It's especially suited to things like natural language processing, and also image processing. So data sets that are difficult to manage within kind of structured SQL traditional type databases, that's where it really thrives, because it can perform this kind of feature engineering on these really large bits of text, for example, like the whole of Wikipedia or like the whole of Reddit, for example. And it can break down these words and phrases. It's got lots of tooling for doing that sort of thing. And then performing computation, machine learning especially, on these data sets. But we don't have to use it just for machine learning. It's also a general purpose kind of data transformation tool as well. So we've talked about splitting your big data into smaller partitions and storing it in memory across many physical or virtual servers. Now, in the case of Fabric, these servers are obviously abstracted away from you. Microsoft manages that for us. We just write the high level code, and they kind of manage all of that, managing these servers and all of that stuff. And we've mentioned that it performs computation in parallel. Okay, so why have Microsoft built their end-to-end analytics platform around this technology? Well, as I've mentioned previously, the data world has converged on Spark. It's really proliferated. It's used by thousands and thousands of companies, and it's become the kind of go-to tool for big data processing. And specifically within this architecture, you can see that even the way that Microsoft are marketing Fabric is the data platform for the era of AI. So that's really important. We need an underlying engine that is capable of scaling up to the data sets that we see in AI, which is normally very, very large data sets. So it's really important to have a platform kind of underpinning this, which is Spark, that is scalable and it can deal with huge data sets. So throughout this course, we're going to be looking at data engineering and the data science experience, but everything's going to be built on Spark. So when should we use Spark? Obviously, we've got all of these different things here. So when do we want to be doing stuff in the data engineering notebooks, for example? Well, some of it might be obvious and some of it might not be. With Spark, we get the ability to write code in a variety of different languages. Obviously, Python, we can write Python. We can also write it in R and also in Scala and also Java as well. I don't think you can write Java actually in the Fabric notebooks, but you can write Java in normal Spark. So if we want to be writing code, if we know how to use Python and we want to be, maybe Pandas really well, then we want to be using these Fabric notebooks. And there's even a piece of functionality in Fabric called single node mode. So when I mentioned how Spark generally is used in a distributed manner, so it manages lots of different nodes, right, for really big data processing. Well, we also have the option to just use one of those nodes. And if you use it in that kind of single node mode, it's a bit like using Python on your own computer. So you can use Pandas libraries, you can use all of your traditional kind of machine learning stuff, scikit-learn or TensorFlow or whatever you want. And you don't have to do it across in a distributed manner. The other time that we want to be using Spark in Fabric is when we want to be doing programmatic data loading, right? Because when we've got our data pipelines, yes, you can do a little bit of kind of looping through various data sets, but it is a little bit limited. And even more so with data flows. It's for people that want that low-code experience for getting data into Fabric. But if we want to be doing more advanced things like automating, running through lots of different tables and performing more heavy-duty calculations, or querying APIs and doing lots of transformations, really we want to be doing that in Spark, in Fabric. It's also really strong for machine learning, which we can't really do anywhere else in Fabric, and statistical analysis, and lots of kind of vector-based math. And like I've mentioned before, when we're analyzing text and images, that's a really good use case as well. Hey everyone, welcome back for video 3 in this series where we're exploring how to use Spark within Microsoft Fabric. And now we're getting into the nitty-gritty of things. And we're going to be going through today the components of Spark. So in my last video, I gave you a bit of an overview of why Spark is important. And now we're going to be focusing on, okay, what is Spark? What are the components of Spark and how we can use it? So if you go onto their website, you can see that it's broken into various libraries. We've got the SQL and DataFrames section of the kind of the API. We've got Spark Streaming, MLlib for machine learning, and GraphX. So what I'm going to be doing is just talking you through this little diagram here and explaining how each of these work and how we can use each of them in Fabric. And across the bottom, you can see we have Spark Core and the Spark SQL engine. And we can interact with this Spark Core and Spark SQL engine in traditional Spark with 5 languages, so Scala, SQL, Python, Java, and R. But in Microsoft Fabric, when we're writing our notebooks, we can see along the bottom here that we can use these languages. So only Python, Scala, SQL, and R. So we can access the Spark kind of API in these 4 languages, okay? Not in Java. And then on top of the core of Spark, we have 4 different libraries. And these are Spark SQL and DataFrames, Spark Streaming, Machine Learning with MLlib, and Graph Processing with GraphX. So Spark SQL, as the name suggests, is kind of like the core construct, at least for most applications using Spark. So we can do tabular data, we can do very large tabular data sets, obviously. And the DataFrame API is very similar, and it's inspired a lot by Pandas. So if you've used Pandas DataFrames, they're very similar. And for the first kind of 10 videos of this course, we're going to be focusing on Spark SQL and DataFrames because they're kind of like the most used part of Spark for most people. We also have Spark Streaming, and in this course I'm not going to be touching on Spark Streaming, but perhaps in the future, if that's something that you're interested in, then I can add that in. Of course, in Microsoft Fabric, we have real-time analytics in the kind of the Custo KQL. You can also hook into Azure Event Hubs. So there is quite a lot of real-time streaming stuff in Fabric already. So there's kind of 2 ways to do streaming in Fabric. So maybe we'll compare those 2 in a future video. Machine learning with MLlib. Well, this is right at the heart of the data science experience. It's one of the libraries we can use to do machine learning within Microsoft Fabric. There's a number of others. We can use Synapse ML as well, is the kind of the Microsoft tool that's available to us. So we're going to be doing 3 videos on MLlib in this series. Graph processing is, as the name suggests, for analyzing, creating graphs and performing calculations on these graphs in a distributed manner. So all of these libraries work on distributed data sets, but we don't have to manage that as such as kind of Fabric engineers. A lot of that, in the most cases, is done for us. Right in the kind of the really advanced section of this course, I'm going to be talking about how you customize how we do different pooling. This video is just a brief overview of the structure of Spark, the different components, just so that you're aware that this is what we have to play with. And in this course, we're going to be focusing on Python and the Spark SQL and DataFrames for most of it, as well as machine learning for a few videos as well. Hey everyone, and welcome back to video 4 in this series where we're learning how to use Apache Spark in Microsoft Fabric. And in this video, we're going to be getting our hands dirty and we're going to be focusing on the Spark data frame. And the data frame is perhaps the most important part of Spark. It's kind of been an evolution in the history of Spark. It didn't used to exist, but slowly the data community have said, actually, we want some data frames. And so now we're going to be focusing on the data frame. How do we use it? How do we create them? And some important parts. What is a data frame? Creating our first data frame. And we're also going to be talking about schemas, because schemas are a really important part of Spark and data frames. So let's start off with what is a Spark data frame. Well, it's a bit like a distributed in-memory table. So it's got named columns and a schema. And the schema defines the columns and the data types for each of those columns. And it's inspired by Pandas data frames, and a lot of the functionality and the code that you write will be very similar to the code that you write if you're used to using Pandas, the library in Python. So I think the best thing to do is just to start walking you through an example. Okay, so here we are in our first example, and I'm going to be walking through step by step what's going on here. So really at the core, we're going to be using spark.createDataFrame, and that's one of the methods we can use to create a data frame in Spark. Now, you might not be using this method very often in practice because there's lots of other ways to create data frames from files or from other data sets. Normally, we don't create a data frame from scratch, but this just gives you an overview of the different components of a data frame. So it's a good place to start. And we can see that we've got our data, and our data at the moment is a list. And within that list is these tuples, and we've got 6 different kind of pieces of data which represent columns. And the other defining feature of a Spark data frame is a schema. So we can create a schema in a variety of different ways. This is the more verbose version. I just want to show you what it looks like to do it this way. We'll look at a different way in the future as well. You'll notice that we're defining specifically what the different column types will be, what their name is here, what the type will be, and whether it can accept null values or not. And we're getting this from the pyspark.sql.types library. And so this is a pretty common piece of kind of boilerplate code that you'll see. This struct type equals this with struct fields for each of your columns. And so when we're creating our data frame, we pass in data and we pass in the schema. And so let's just run this and see what we get. Okay, so we can see that our Spark session has been started and we've done 3 Spark jobs. And we can see that we've printed the schema using df.printSchema. And so this is just telling us, it's kind of playing back to us what we've declared as the schema. We've got first name, middle name, last name, ID, gender, and salary. And we can also call df.show to show the first few records in this data set. So we can see the kind of the structure, has it pulled through okay, are our columns correct? And we can see that pretty much, yes, it is. And so we can inspect the type of the data frame, and we're going to see that it's a pyspark.sql. So we're using the SQL API, and we're using the data frame, or it's a data frame object. So we have successfully created a data frame. So that's good. And I just wanted to focus on the schemas in a bit more detail. So why do we have to define a schema? Because you might look at this and think, oh, that's a bit painful. Do I have to do that every time I want to create a data frame? Well, the answer is yes and no. And there's a number of reasons for that. Every data frame within Spark needs a schema. So there's a variety of different ways that either we can declare a schema or we can ask Spark to try and infer the schema based on what we throw at it. So typically it's best practice to declare your schema because there's a number of different benefits to that. Number one, you know that the schema is going to be correct because you've declared it. And so you're never going to get a data type problem further down the line. Number two, and we'll look at this in the next lesson, is there's also the option to infer a schema. But when we have a data set that is, say for example, you're reading data from a CSV, and that CSV has 200 columns, we can call in infer schema equals true on our Spark data frame. And Spark's going to go through every single column. It's going to have a look at the data in it and try and infer the data type. And that can be quite an expensive operation, especially every time you're reading these files. You've got to go through, okay, try and infer again. So it saves us money, ultimately at the end of the day, and time in processing power. So there is another way that we can define a schema, and it's using this data definition language, and it's a bit more readable. So this schema here is the same schema as what I've declared up here, just using a different way. So here we're using data definition language, and it does the same thing. So if I execute this one, we've got the same result, and it's a bit more user-friendly, let's say. So you can declare schemas like this. Hey everyone, and welcome back to video 5 in this series, and we're learning how to use Spark within Microsoft Fabric. And in the last video I looked at how to create a data frame kind of from raw data, and we explored the importance of schemas as well. And in this video we're going to be taking it a step further and making that a bit more useful, and we're going to be learning how to read and also write files into a Spark data frame. So as ever, all of the code that I'm going to be showing you today, as well as the dataset that we're going to start using, which is this one, propertysales.csv, is available on the GitHub, and I'll leave a link to that in the description below. But this is what our data looks like. This is not big data. This is 3 rows. This data describes various sales of properties that have happened in these 3 cities. So there's only 3 properties that have been sold, but it helps us just to understand, okay, the mechanics of Spark and how it works without getting overloaded with big data just yet. And what I've done is I've set up a Lakehouse here, and there's nothing in my Lakehouse apart from in my files area. I've added this property sales.csv. So you can go to GitHub, you can download the data and just need to upload it into this files area of the Lakehouse. And to do that, you just need to go to the Lakehouse. This is my Lakehouse here, Spark September. And well, there's a variety of ways to do it, but you can click on these ellipses here for files, upload files. And there it is there. So if you go back into our notebook view, so I've started this notebook, which you can also find on the GitHub. And so we're going to start by reading in that CSV into a data frame, because the data frame is where everything happens in Spark, basically. We want to be getting data from files into a data frame so that we can do transformations, filtering, and all that cool stuff. And we're going to start with this basic declaration here. So we're giving our CSV path, which is files/propertysales.csv, once you've uploaded the data there. And to read a CSV file into a Spark data frame, we need to call spark.read.csv. And Spark is the Spark session. If we hover over it there, we can see it's the entry point to programming Spark with the dataset and DataFrame API. And if you're using, or if you've used Spark in the past, you need to initialize this session. Within Fabric, it's already initialized for you, so you don't need to do anything. You just call spark.read.csv and it's available to us. And from here, we're going to pass in this, which is the path. So we're going to tell it, okay, read the CSV from this file path. And we're also going to tell it header equals true, because our CSV file does have headers. So if I just run this here, okay, so here I've just called at the end of this cell display df_CSV. So that is what we've saved our data frame as, the name of our data frame. So you can see here when we call display in Microsoft Fabric or in any IPython notebook, then we get this kind of interactive table, which is our data frame here. And we can have a look, and we can look at the structure of our data frame. And it looks about right. You know, it's got all our columns, it's got the headers correct. We can export it if you really want to do that. But what we can do is we can explore the data types by calling df_csv.datatypes. And you can see that there might be a bit of a problem here, because we've got sales price, which is a US dollar value. And currently it's reading in the data type, the D type, as a string. So if we want to be doing any sort of aggregate functions or calculations on that sale price, is not going to work because it's reading it in as a string. And this is just hammering home the importance of a schema. So another parameter that we can pass into read.csv, and this is what I was mentioning in the last video, is infer schema. So in my last video I mentioned that this isn't perhaps best practice. It's a bit lazy because it's forcing Spark to do the work for us. So it's going to go into each of these columns and have a look at the data that you've given it in this file. And now if we run it again, this data types, well, it can see that now the sale price is an integer. So that does make kind of sense. But sale price might not always be an integer. So in our kind of sample data that we've given it here, yes, it is an integer, but I'm no property expert, but I would guess that it is possible to not be an integer for a sale price, especially if you're maybe converting from other currencies, or you don't know how this is going to work. So rather than inferring the schema, you might want to explicitly define the schema and maybe define that sale price not as an integer but as a float instead. So that's a little bit about we've read our CSV, and now what I want to do is just to kind of build up that muscle memory of reading from files, and we can also write to files. So now that we have our df_CSV, what we're going to do is practice writing that out to a JSON file, because just as easily as we read it in from a file, we can also write it out. So this time we're going to be using the data frame itself as the base of our function. And so we're going to call df_csv.write.json. So we're going to write this file, and the format is going to be a JSON file. And we need to pass in both the file path and the file name that we want to give it. So here I'm passing in files/JSON. I'm going to create a folder called JSON, and I'm going to put this JSON file in it. And we can pass in various modes as well when we're writing files from DataFrames. You can have overwrite, or append, or ignore, or error, I think is another one. Okay, so we're going to be using the mode of overwrite here. So if it already exists in this location, we're just going to overwrite it. Okay, so I've run this cell here. Now let's have a look in our files location. We'll just update this path, and we can see we have now got this. And we've got our property JSON here. So this is what our file looks like under the hood of Fabric. So we've saved it now as a JSON file, so that's good. So now what we're going to do, strengthen those muscles up again, and hopefully you're getting familiar with the syntax here, is now we're going to read that same file back into a data frame, and we're going to call it df_JSON. So again, we're doing spark.read, this time from a JSON file, not a CSV file, and we're going to just display the results. So again, it's working well. We've got our structure here. We've got these different columns. And just to practice a little bit more, we're going to be doing df_JSON.write to Parquet file. Okay, so that's worked. And I'm also going to save two files here. So I'm going to save two Parquet files. One is property sales, and one is property sales 2. Okay, so now let's have a look at what we've got here. We can go back into our Lakehouse Explorer and refresh this. Okay, so now we have a Parquet section, and we've got property sales.parquet and property sales 2.parquet. Happy days. Okay, what's the point in all of this? Well, we're trying to build up the muscle memory of writing to files and reading from files into and out of data frames. And if you go to the documentation, and I'll leave a link to this one in the description below, and you can see all the different file types that we can read from. I've shown you some of those, like JSON and CSV, and we also looked at Parquet as well. So this is a really good resource for you to learn a bit more about all the different options for reading from files. Okay, so now we have our Parquet, and just to prove that we can do this again, let's read our Parquet file from this one that we've just exported, and again, looks like that's working well. Okay, so we understand that. Let's go up a level, and typically we don't query an individual Parquet file. Normally we're going to be pointing at the folder that it lives in, and we're going to be wanting to create a data frame from all of the Parquet files or multiple Parquet files under that structure. So now we're going to learn how to read multiple files in the same folder into a data frame. So there's a few different ways that you can do this. Perhaps the most simple kind of looking way is to use this kind of wildcard operator on the file path. So here, the reason why I saved 2 of these files now here is that we want to combine those 2 Parquet files into one data frame. And you might want to do this because maybe this is January the 1st, 2023. You have a Parquet file for January the 2nd, 2023, or you have a Parquet file. Generally we save data in lots of different partitions or different files in these kind of big data projects. So it's a really common operation to kind of gobble up all of our Parquet files and put them into one data frame so that we can analyze them. Okay, so this has worked. We've got df.allParquet. And another little handy thing that we can use is exploring the metadata of the files, because we've seen that this cell has successfully run. But how do I know that the data in this data frame contains data from each of these 2 files? Well, the answer is, what I've done here is the same query. So we're doing spark.read, and you can use a backslash here to kind of go onto a new line within these cells just to make it a bit more readable. So you've got spark.read, .parquet, and again, we're doing that kind of wildcard operator on the file path. So we're saying, get me all of the Parquet files in this folder. And then we're going to be doing .select. So .select is something we haven't looked at yet. But what this line is showing us is, okay, select everything that is in this data frame up to this point and add on another column. And this is a kind of special column name, underscore metadata, that Spark provides us. So let me just run this and we can see what this one looks like. Okay, so we've got all of our existing columns as we've seen before, but then at the end we've got this underscore metadata column, which is interesting. There we go. So now we can explore this metadata column in a bit more detail. We can see the modification date, the row index, the file size, the file name, and the file path, that this row where it originates. So that's a really good way of checking that, okay, we do actually have the data that we think we have. Okay, so that's it for this lesson. For further learning, there's lots of things to learn about reading from files, and I'll leave a link to the documentation here, again in the description for this video. And in your own time, you can look at more complicated scenarios, such as ignoring corrupt files, more elaborate filtering of that path using something called path glob filter, and also more techniques for dealing with recursion in kind of nested folder structures as well. Hello and welcome back, and this is video 6 in the series where we're learning how to use Apache Spark in Microsoft Fabric. And today we're going to be focusing on how to read and write data frames to Lakehouse tables. So obviously up until this point we've been working with data frames, but in Fabric really what we want to be doing is saving those as Lakehouse tables so that we can use them for analysis, Power BI, we can do direct lake mode looking into these tables. So once we've done our transformations and our cleaning and all these kind of things, we save it out to a table. So that's what we're going to be focusing on today. So picking up from the last lesson where I showed you how to create data frames from files, we're just going to start by grabbing one of the files that we used last time into a data frame. So we have some data to work with. Okay, so now we have some data. And you might be familiar with this if you watched the last video, and it's property sales data. So we've got sale prices of 3 properties. It's got some other variables like the city, the agent that sold the property, the address, and the type of property. Happy days. So one thing that we need to be aware of is a few limitations. So if we want to write our data into a Lakehouse table, there are a few limitations about what we can call columns, and I'll leave a link in the description below to this, but there's a few different things to bear in mind here. Specifically, we can't have any spaces. So if you've got spaces in any of your column names, it's not going to allow us to write that into a Lakehouse table. And it also gets a bit funny about special characters. So any special characters are not generally going to go down very well with our Lakehouse. So if you look at our data set here, I kind of deliberately made this a bit of a dodgy data set so that we can clean it a little bit. So you can see that, as is commonplace with a lot of data projects, we've got a trailing space here in the address line. So that's not going to work. And also this $sign, that's not going to work either. It doesn't like that. So if we were just trying and write this to a table, it's not going to work. It's going to say, no, I'm not dealing with those columns. You've got to change those. So what I'm going to start by doing is use this function that we can call on our data frame called with column renamed. And it's just going to rename the columns. So here what I've done is you pass in the name of the column that you want to rename with the new name for that column. And I've just chained 3 of these together because there's 3 column names that are not going to work. So let's just call that, and then obviously I've assigned that back to our data frame variable to kind of overwrite it. Okay, so that's been successful. Now we should have, let's just do df.print schema again, just to double check that that has worked. Okay, so now we can see that our sales price underscore USD. So that is going to work. And also our address has, we've removed that space from the address line. Okay, so now we have our columns in a suitable structure for writing to a table. So writing to a table, the code for this is fairly straightforward. What we want to do is on your data frame, you want to call write, and there's a few different modes that we can use. So write.mode overwrite will overwrite everything in that table with whatever you're passing in this time. And we're going to be using format delta. So as you may know, all of our tables within a Lakehouse are built on top of this Delta Lake format. So they're actually Delta Lake tables with Parquet files sitting underneath them. And so we want to be calling save as table, and we pass in the name of the table that we want to call our table. And if we do save as table, what that's going to do is save it as a managed table. And in Spark, there's two different types of table. One of them is managed and one of them is unmanaged. And the managed table is kind of what we want to be using in Fabric most of the time, because it means that both the metadata and the data are being managed by Spark. And we're just going to run this cell. Okay, so that's succeeded. Let's just refresh our tables. And there we go. You can see we have property sales as a table. And we can see we've got this little triangle here, which means it's a Delta table in Fabric. And I mentioned there's 4 different modes that we can use when writing tables. We can use the overwrite functionality, which is what we've seen previously. We can also append. So if we've got daily data, for example, and we just want to append today's data onto the really long kind of log data of all data from all time, then we might want to use append. We can also use error, which will throw an error if that data already exists or if that table already exists in our Lakehouse tables area. And we can also call ignore as a write mode. And what this is going to do is, again, it's going to fail, but it's going to fail silently, and you can handle that using it in a different way to how you would handle your error if you were to use the error mode. So these are some of the different write modes that we have available to us. And this is what I was talking to you about, the managed versus unmanaged Delta Lake table. So just for fun, if I run this code here, what we've got is df.write.mode overwrite format delta, and this time we're doing save. Okay, not save as table, but save. And we're going to give it a path, and that path is going to be in the files section. So we're not dealing with a managed table. It's not in our tables section. This is an unmanaged Delta table. And you can see here, what we've got here, I've called it unmanaged.delta. So that's probably not something you're going to be using on a day-to-day basis, but useful to know the difference between managed and unmanaged tables. Hello, welcome back to this series. Now we're on day 7 of this series where we're learning how to use Apache Spark within Microsoft Fabric. Obviously, Spark is the engine that we use in the data engineering experience and the data science experience. And today we're going to be starting to look at various data engineering kind of tasks, or at least how do we operate on DataFrames to perform really common actions. And this is what we're going to be looking at today. We're going to be reading some data into our data frame, viewing our data, exploring schemas, doing some column operations, adding new columns, removing columns, and that's what we're going to be doing today. So let's dive into it. As ever, the notebook is stored on GitHub, so make sure you go to github.com/learn Microsoft Fabric, link in the description. You can follow along with me here. So let's start by just getting some data into a data frame. As we've done many times before, we're using spark.read.csv. And again, this is using the property sales dataset, which I've stored in our Lakehouse files area. That dataset again is available on the GitHub, so you can go there to check that out. Okay, so now we have some data in our data frame. Let's just show that. So we can use a few different methods to visualize our data, and each of them have positives and negatives, I would say. The first way that we can look at our data in a data frame is with df.show. So it's just going to print out this kind of like textual based summary of what's in our data frame. And it's quite good because it tends to use space quite well. So you generally can see all of the columns unless you have lots and lots of columns. But for small data sets, it's useful. Another way you can view your data is by calling display and passing in the data frame that you want to visualize. And we've seen this before. It gives us this interactive view of our data. We can do some more fancy things like change the column widths. And we can also do ordering. So if I want to look at my data, what the highest sales price is, well, it's this one. You can also export this to CSV, JSON, XML. And you can also visualize your data as a chart. Not the best visualization. Hopefully we can create some better ones than that, but it gives you a bit of a very quick overview of the data. So that's display. We can also call df.head, and this is just going to show us the first X number of rows. So I'm passing in 2. So in this case, what I'm doing is saying, okay, get me my data frame, and I just want the first 2 rows of that data frame. You can have millions and millions of rows in this data frame. I only want the first 2. And then you're passing that into the display function. So you're saying, okay, I want that fancy interactive table view, but I only want the first 2 rows. So that's what that's going to look like. Next up, I want to look at schemas. And right from one of the early videos, I explained the importance of schemas in Spark and in DataFrames. So how do we interact with schemas? Well, we've seen this one before, the print schema. We can call print schema, which is a function of our data frame. And we can see, okay, these are the different columns, the column types, and whether it accepts null values or not. So that's printing out the schema, as the name suggests. Well, we've seen this one before, df.datatypes. And we can explore just the data types, and it returns a list of tuples, and each tuple has the column name and the column type, which is useful. Again, we can use that in a variety of different ways, and sometimes it's good to know what the data type is of our columns, but it's not returning the full schema. We don't have this null values in that method. But what if we actually want to return the schema, not just print it, but what is the actual schema? Well, we can use df.schema. And if you've been following this series right from the beginning, this might start to look familiar to you. We've got the struct type and the struct field, which is the way of defining schemas within Spark, or at least one way. So this could be really handy to access the actual schema of a data frame. Say, for example, you want to do something like this. So in this example, we're using df.schema, but we're storing the schema as source schema, for example. And this saves us having to explicitly write out our schema for a new data frame if we have one that already exists. Can you imagine if your data frame has 300 columns? Then the schema is going to be pretty large. And so if we can just extract that schema, and maybe we want to create a new piece of data that uses that same schema, well, we can just call df.schema, and then when we're reading in a new file, we can just use the source schema, right? We can pass in schema equals source schema, and so the CSV file must conform to that schema. So that's a useful thing to know there. Next up, let's move into some column operations, and we can view which columns we have by calling df.columns, and here it's just going to return us a list of the column names. Next, let's look at, okay, how do we select just one column? Now, in our data set, we've got this column called type. So what I'm doing here is I'm calling select, and I'm passing in the column name that I want to return. Then I'm calling .show to print the results, basically, into this workbook, into this notebook. And one thing to note is if I just do type on this, let's just remove this for a second. So here you can see that it's returning a data frame. So we're selecting one column, but it's not returning a column type. It's giving us a data frame, which is useful because we can do data frame operations on it. So that's something to bear in mind with the select. Okay, we can also do things like renaming columns, which we've seen in the last video. So we can call df.withColumn renamed, and we're going to pass in the old column name and the new column name. So we want to change it from address with a space to just address. And if we just run this cell, we can see that the column name here has changed, which is what we wanted to do. We can also pass in a list into this select statement. So if we want 2 columns, then we're going to pass in a list with the column names. So address and type. So that's going to return 2 columns. If we want to add some new columns, perhaps I wanted to do a new variable called 2x the sale price. I don't know why. This is just a dummy example to show you the functionality. Well, I can use this with column function. So I can call df.withColumn, pass in the new column name that I want to give this column, and then some sort of logic as how you calculate that column. So in our example, we're doing 2 times the sale price. So I'm going to call df, I'm going to get the sales price column, and I'm going to times it by 2. And so let's just see what that does. Okay, so with all these examples, we need to assign what we're doing here to the data frame variable, and that will save this into this data frame. Okay, so here we have our data, and we can see it's added this new column called 2x sales price, and lo and behold, it's 2 times the sales price. So happy days. Next, we're going to look at removing columns. Oh, we've made a mistake here. This 2x the sales price, actually we don't want that. So what we can do is call df.drop, and we pass in the name of the column that we want to drop. Let's just run this. And again, we're assigning it back to the df variable here to save these changes. Okay, so now we can see that our data frame has been updated. That column that we just created has now been removed again, and we're back to where we started. Hey everyone, and welcome back. And now we are on day 8 of this series in which we're learning how to use Apache Spark within Microsoft Fabric. I hope you've been enjoying the series so far. If you have, then leave me a comment, like this video, do all that good stuff, share it with someone that you might find this useful. That would be really helping me out. Thank you very much. Now today we got a very exciting topic. We're going to be looking at DataFrame filtering. So we're going to be looking at the various ways that we can use to filter our data frames. As ever, this code is available on GitHub, github.com/learn Microsoft Fabric. I'll leave a link in the description so you can follow along with this tutorial as well. And we're going to be starting off with getting some data that we're going to be filtering. So what I'm going to be doing is calling spark.sql. So this is the first time that we've seen this. This is how we can read some data from our Lakehouse tables into a data frame. So to do this, if you're familiar with SQL, this will look familiar to you. We're just going to call spark.sql, and we're going to select star, which means get all the columns from Spark September, which is the name of our Lakehouse here. And our table is called property sales, this one. Now this is the same as if you can actually drag this into the notebook, and it will give you the same piece of code here. So let's just run this. Now we've got a limit of 1,000, so it's going to only return 1,000 rows, but this table has only got like 3 rows in it, so it's not particularly important. Okay, so now we have some data, and this is what it looks like. We're using the same data set. So if you've been following this series, you're familiar with this. We've got some property sales data, and it's got the dollar values of 3 different sale prices for houses. It's got the type of the house, the city, the agent that sold it, and the address. So let's look at how we can filter this data frame. We can start with some simple methods, and we'll kind of build up the complexity. So the first and kind of most obvious way of filtering a data frame is by calling df, which is what we call our data frame up here, df.filter. So this is the core kind of filtering function available to us within Spark. And we can pass in here, okay, what column do we want to do our filtering on? And what do we want it to be equal to? So here we're saying, okay, I want to filter our data frame and I want to filter it and only return values where the city is equal to New York. So if I just run this, we're actually going to get the other ones come through as well. And as well as kind of equality, we can do the opposite. So not equal to. So in the second statement here, I'm also asking it to get us all of the cities that are not New York. And there's two ways to actually do the not equal to. One is kind of the more traditional Pythonic way of doing exclamation mark equals. And you can also use this df.filter with a tilde, but to me, I don't really like this way. It's not very readable, at least for me. I think this is more understandable for people in the data space. You can read that very simply, and readability to me is very important. So this is what we get. From our first statement, we've called .show, right? So it's going to print out the results into the notebook for us to have a look at. And bearing in mind, this is what our original data looks like. So New York, there's only one row that has this. So we'd expect to see one row, which is what we've got here from our first statement. Our second statement is showing two results. So everything that's not New York. And the same for the third one, because it's doing the same functionality, it's just expressed in a different way, a worse way, IMO. Okay, so let's expand this a little bit, and we can use some other pieces of conditional logic to filter in different ways. This one is starts with and ends with. So if your column is of type string, then you can use starts with and ends with by passing in a string here. So here we're looking for columns that start with L. So we've got Los Angeles here, and cities that end with TA, which is Atlanta in the second example. We can also pass in multiple conditions. So here, what we're saying is, okay, from this data frame, I want you to filter it, and I want you to get me all of the cities that is not Atlanta, and the sales price is greater than 400,000. So let's just see what that gets us. Okay, so if we were to just do one of these, what would we get? Well, with one of them, where the city is not equal to Atlanta, it would look like this. One of the sales prices is 345,000, and one of them is 700,000. So if we add this second kind of condition into this filtering statement, that's going to remove the lower sales price so that we've only got this 745,000. So this is how we can work with multiple conditions under the AND scenario, and it's just a single ampersand for doing the AND. We can also do an OR condition. So if the city is equal to Atlanta, or the city is equal to Los Angeles. So we're saying, okay, if it's either of these cities, then return me the results. So if I just call this, okay, and these are our results. So we've returned two records here, one for Los Angeles and one for Atlanta. But this is a bit clumsy, writing it like this. What we could also do is check if the row value is a member of a list. So we can define our list. So now we're going to rewrite this statement that we've just looked at using a slightly different method. So what I've done is I've defined a list called cities we care about. Sorry to anyone that lives in New York, but cities we care about is Atlanta and Los Angeles. And then in our filter statement, we can call df.city.isin, and we can pass in that list. So we're saying, okay, filter this data frame, look in the cities column, and if the value is any of the values that we've defined in this list, then keep it in the data set. If it's not, I don't want to see it. So if we run this, this is what this is going to look like. And it's exactly the same as what we got before, but it's a bit more scalable, right? Because if we've got 50 columns in here, then we don't want to be writing this kind of statement. We want to be adding it to a list, and then as new cities get added to that list, we don't have to change this line of code, okay? So that's membership of a list. Now, Another thing we can do is contains. So we looked previously at starts with and ends with, but we can also do contains. So in this example, we've got df.type contains house. So we've got a few different, if we again go back up to our data of the types, we've got a detached house, an apartment, and just a house. So what we want is only the records that have that mention house anywhere in their value. So this is what this looks like, and we've returned two results. We've got the detached house and the house. So that's kind of using this Spark function. And if you're a SQL user, then probably what's screaming out to you right now is, oh, this is a bit like the like functionality in SQL, where you can define select star from table, where this value is like, and you use the percentage signs on either side. Well, funnily enough, you can do exactly the same thing within Spark. So you can also call df.filter, df.type.like. So this is our column name, and then we're calling .like. And you can use the same percentage sign. And obviously, if you know SQL, then there's three different main options that how we can use this. If we put the percentage sign at the beginning of the string and at the end of the string, then we're saying, okay, return me all the values where house is included, either at the end, at the beginning, anywhere in the middle, I don't care. In this second example here, where we're calling house with the percentage sign after, we're saying, okay, this string must start with house. It can have anything after it, but it needs to start with house, okay? And then finally, we have kind of ends with. So if you put the percentage sign at the beginning of this string, there's going to be %avenue. What that's saying is, okay, get me anything. I don't care what comes first, but the final characters of that string have to be this. So let's call all of these now and see what we get. Okay, so we can see that the first one, this house with two percentage signs, looks like this. So we've got anywhere that house exists in the string, return that. So we've got two results. With this one, we're saying, okay, get me only the records that start with house. So now we're only getting this one. The detached house has been dropped. And finally, we've got ones that end with avenue, and this is the df.address. And we've only got one record that does that. So another way that we can use SQL expressions is like this. So we can call filters that are a bit more SQL-y, let's say. So df.filter, and we're going to pass in a string, which is basically a SQL statement. And it's going to be city is not equal to Los Angeles in kind of these single apostrophes. And we've also can use these kind of two angle bracket things that we see in SQL for meaning not equal to as well. So these are going to return the same results. Okay, so we can also do df.where, and you might see this in some documentation, but for any of the functions that I've shown you, calling df.where is the same as df.filter. So it gives the same result within this Spark SQL API. It does vary a little bit in some other parts of Spark, but for everything that we're doing, it's the same. So for example, if I do df.where, it gives us the same results. Just something to bear in mind. Hey everyone, and welcome back for this video. We are in video 9 of this very, very long series about Spark and how to use it within Microsoft Fabric. And today we're going to be looking at the GroupBy functionality and creating aggregates from those GroupBys. So how do we group up our data and perform kind of basic calculations on these different groups, which is pretty much a core exercise that we do in, well, any sort of data processing tasks, really, as I'm sure you're familiar with. So, as ever, the code that you're going to see here is available on the GitHub. I'll leave a link to that in the description below. If you're enjoying this series, give this video a like. It really helps other people find this content that you might think is useful. And if you do have other colleagues or people you work with that you think might find this valuable, I'd be grateful if you shared it with them as well. Okay, so let's get going. And to kick us off, we are going to need some data. And what I've done is I've created a slightly extended version of the data that we've been using up until this point, because it's very difficult to do group by operations on a data set with 3 rows. So again, this will be on GitHub as well. We've got property sales extended.csv. So I've just added that into our same Lakehouse, as you can see here. Into the files location, we've got this one here, property sales extended.csv. So let's go back to our notebook and read it in and see what it looks like. Okay, so let's just read this in as a CSV. Headers equals true, infer schema equals true. Saving that into the variable df, and then we're calling df.show to just see what this looks like. Okay, so now we have, again, our address, our type, our city, our sale price, and now we've got a few more rows to play with. So this is where it gets interesting. Not quite in the realm of big data yet, but we've got about 20 rows. And so what we're going to be doing is grouping this data by various columns and performing some aggregate functions on this sales price column. Perhaps we want to know what the average sale price in New York was, or what the average sale price for each agent was. That'd be interesting stuff to figure out from an analysis point of view. Okay, so let's kick us off with a nice simple one. And the syntax in Spark, or at least pyspark, is df.groupBy, and you pass in the column that you want to group by as a string. If you've got one column, we'll look at multiple columns a bit later on. And then we're going to call the aggregate function that we want to become the aggregate. And then we're going to call .show. So what I'm doing is I'm getting a count of the rows, but after we group by the city. So I'm saying, okay, how many sales are there in each of these cities? So in Los Angeles, we've got 5. In Atlanta, there's 4. New York, there's been 8 sales in our data set. So that's interesting. We can also do perhaps the maximum. So we've got count, we've got max, we've got min, average, which is AVG. And again, this is going to return the agent and the max sales price. So what their biggest sale was for each agent. And this is okay. We can see that it's not particularly nice having this max sales price as our column header. So what we might want to do is rename that, right? So there's a few different ways of doing that. First, we can use our good old friend with column renamed, and we've looked at that quite a lot before. So this probably is very similar to what we've just seen here. We're doing a group by with a max, and then after that, we're just piping that into with column renamed, using the max sales price as the column we want to rename, and we're changing it to max underscore sales price, for example. It's a bit cleaner. And then we're showing that, and I'll run that in a second. But the other way of doing this is by using ag. So this is like aggregate function, and we're going to be using this a few more times in a few different ways. So it's useful to understand this syntax. So what we're doing here is we're saying, okay, group my data frame by the agent column. And then I'm going to perform a generic aggregation. So I'm calling AGG. It's like, I want to do some aggregate, but I don't know what yet, or I haven't told you which one yet. And then we're going to call in max. And now that we're not using the functionality built into the DataFrame object, we need to import it from this library. So we need to call from pyspark.sql.functions, import sum, import max. Like, we're not using sum in this example, but whichever one you need to use, you'll need to import it at the top. Okay, so now we've got this max and we're passing it in, right? What we're also doing is providing an alias. So in this style of working, we don't need this column renamed because we're passing everything into this aggregate function. We can use this .alias. So let's just have a look at the results here. Okay, so pretty much the same, or exactly the same. We've got our agents and their max sale price, calculated using 2 different ways. Okay, so now we're going to be expanding that second method of defining an aggregate. And in this example, what we're doing is very similar. We're going to be grouping by the city this time, and we're going to be defining 2 different aggregate functions. First, I'm going to be getting the maximum sales price, which is what we did previously. And I'm going to round it to 0 decimal places. And again, we're going to need to import that from pyspark.sql.functions. Then we're going to pass in another aggregate into this ag function, separated with a comma. So we're also going to get the average sales price. And again, we're going to round it and we're going to give it an alias of average. So let's see what this gives us. Okay, so we've got for each city, Los Angeles, Atlanta, and New York, we've got the maximum sales price, which is this. And we've also got the average sales price, both rounded to 0 decimal places. Okay, so we're starting to build a bit more logic on top of this, a bit more complexity. We can also do filtering on an aggregate. So if you're used to using SQL, this is similar to the having statement. So after a group by, we can do having, and it filters out results of that group by. So in Spark, what that looks like is calling again group by the city, the aggregate. These are all the same as before. We've got 2 aggregate functions, the maximum sales price and the average sales price. And then on the end, we're chaining on a where statement, and where the column, which is again something that we have to import if we want to do it like this, where this is greater than or equal to 500,000. So there we go. So there's only actually one city with an average sales price of over 500, and that's Atlanta. Just before you send me lots of comments and emails or whatever, this is completely made up data, by the way. So I don't live in America, but I'm pretty sure the price of property in Atlanta is less than it is in New York and Los Angeles, but you can let me know about that in the comments. Okay, so next let's look at grouping by multiple columns. And as you might have guessed, that's quite simple as well. We can just do df.groupby and we pass in a list of columns. So here we're passing in the city and the agent. And the aggregate function we're using here is average. So .avg, we're calculating the average on that sales price column. So now we're going to get more rows because it's kind of doing a group by of all the different combinations of city and agents in our data set. We've got Atlanta and Sheila. The average sales price is 259. We haven't rounded it this time, but you know how to do that if that's what you need. So that's how to do group by multiple columns. Hey, welcome back, and now we're on video 10 of this series, and we're exploring how to use Apache Spark within Microsoft Fabric. And today we're going to be focusing on handling missing values within our data frames. And you might be wondering, why do we want to handle missing values? Null values and NAs are just part of a data frame, right? Well, within Microsoft Fabric, we want to be using our data frames for data science, machine learning. And a core part of machine learning and preparing our data sets for machine learning is generally to do something with missing values, because most machine learning models don't really like missing values. They can't handle that. It needs to have something in there to learn from, right? So a common step in data preparation for machine learning is to remove or handle in some way missing values. And today we're going to be looking at the different ways that we do that within PySpark in Fabric. So I've got a new data set for this lesson. It's called Property Sales Missing. As always, it's available in the GitHub. I'll leave a link in the description below so you can follow along. And all you have to do is upload this into your files area of a Lakehouse and we can read it from there. So let's dive straight into this. So first on the why, well, I've already mentioned the why. It's dealing with missing values. It's a common task in preparation for machine learning. And there's a few different ways we can do this. And which method you choose depends on generally the business question that you're answering for your data science project and what makes sense for your domain or your data set. Because sometimes you might want to completely remove a row if the value in one of the columns is null, because maybe it's like a really important thing, or maybe it's your label. You know, if you don't have any data to learn from, then might as well remove it. But there are other ways of dealing with missing values as well that we're going to be looking at. Okay, so let's grab this data and we're just going to read it, the CSV, into a data frame and then print the results or show the results into our notebook. And here we go. So if you've been following along, this data set you're probably absolutely sick of by now, but I'm going to keep on using it. And it's got sales data for houses or property, and we've got the sale price in US dollars, who sold it, the agent, the city, the type of like house or apartment that it was sold, and the address. And we can see that unfortunately some of our agents have failed to update the database with the sales amounts for some of these sales. So we can see that we've got null values for some of the values in this column, which is unfortunate, but that's what we're going to be dealing with today in a variety of different ways. Okay, the first method is to just drop the rows that have null values. And this is pretty drastic, but you might be wanting to do this, kind of taking a bit of a sledgehammer to your data. So you can see here, we've got a lot of null values. So what this function is doing is if we've got any null values in any of the columns, remove the row entirely. I don't want to see it, right? So this is what this looks like. We've actually only got 2 rows that have data in each of the 5 columns. So that's what that looks like. But we can also pass in, if we want to get a bit more surgical with how we do this, we can pass in this how. And if we hover over drop, we can get a bit of insight into how this drop works. And there's 3 different parameters that we can pass into the drop function. There's how. So how do you want to drop? Well, we can have any. So drop a row if it contains any nulls, or drop a row if all its values are null. So if we just print these, you can begin to guess what this is going to look. With the any, it's the default, so it's going to be exactly the same as what we had here. If we've got how equals all, then we need all of the values in that row to be null for it to be dropped. And in our data set, we don't have any rows like this, so it's going to be the same as what the input was, but it's something to bear in mind. Now the other one to mention, if we hover over this again, just to look at the documentation, we've got threshold. So okay, maybe we don't want a binary drop everything if there's a null value. What if we want some sort of threshold? So here, what we're going to do is start with a threshold of 5 and see what this looks like. Okay, so with a threshold of 5, basically that's what we were looking at before. So the threshold is saying there must be values in this threshold number of columns. Now the threshold is 5. So we're saying, and we've only got 5 columns. So what this is saying is return me rows where we have data in 5 columns, which is all of them in our case. So again, we get just these 2 rows that's completely full. But what happens when we drop this threshold? We start to get slightly different results. So now we're looking for rows which have 4 out of the 5 columns. You know, we have values in 4 out of the 5 columns. So this one is missing just 1 value, it's this one. And these ones are missing the address. So that meets the threshold. We've got 4 columns with values for this data. And if we drop that down again, make the threshold 3, we're saying we want values in 3 of the columns. So it adds in this row has just been added now. So we're pulling through this one. And this one where there's 2 nulls, so we've got it meets the threshold of 3. And I don't think there's anything below that in our threshold, but that's how the threshold parameter works. What we can also do is specify. Perhaps some columns are more important than others, okay? So the other parameter that we can pass into this drop function is subset. So drop the rows where this column, our sales price, is null. This is what this is going to look like. Okay, so now we've got a completely clean sale price column. We've still got nulls in the address column because that wasn't part of our subset. We're not interested in the nulls in that column. We only care about the nulls in the sales price column. And now we've removed them. That's removing null values, and that's how that works. And obviously with the subset, you can also pass in a list. So if I also give it address, oh, that's not a list. So now it will remove all of those things because our subset has been expanded to include the address as well. So that's just how that works. Okay, so that's removing rows where we have null values. Let's look at filling, because another method in data science is to fill some of these missing values. Maybe we don't want to remove that whole row completely, but we might want to fill it with a value that makes sense for the analysis that we're carrying out. So two different methods here. Again, we're calling df.na.fill this time. And we're going to pass in two parameters, the value. So this is what we're going to fill in the empty value with, and our subset again. So we're saying, okay, I only care about the address column. And if there's any null values, I want you to replace the value, or I want you to fill in the value as unknown address. And so there's two different kind of syntax ways of doing this. Either you can call df.na.fill or df.fillNA. It's potato, potato, as they say. And so now we can see that we've got unknown address, unknown address, unknown address, unknown address for all of the null values in that column. But because we called the subset, none of our sales price is obviously changed or updated. So that's how we do that. We can also do it for numbers. So in our sales price column, we can kind of impute the value 0 for all null values. So this might not make sense, but I'm just showing you the functionality. We've replaced all the null values with 0. And again, if I was to add in the address into the subset, what would you expect to happen here? Well, actually nothing happens, because what happens is it looks at the data type of your value, which is 0. So it's a number. And Spark knows that the address column is of type string. So if you add in a column in your subset that is different to the data type in your value, then it's just going to be ignored, okay, from this fill operation. So that's one thing to bear in mind. So you might be thinking, okay, filling this column with 0 is a bit, that's not very representational, that's not a very good idea. And you'd probably be right. If you fed this into a machine learning algorithm, those zeros are going to seriously affect the predictions. And I doubt that you can get an apartment in Atlanta for $0. So one method that is used just to show you the functionality, I'm not saying this is what you should do, but we can use feature engineering part of Spark. This is the first time we're looking into the more machine learning type libraries, and we can use this imputer. So imputation is a whole field in itself, like the right strategy for imputation of missing values. But what it means is we're going to look at all of our existing data, look for the patterns, and in this case we're looking at the mean of the existing values, and we're going to impute. So we're going to replace the missing values with the mean for that column. So the way that we have to do this is, well, we need to import our imputer, and we're going to give it the input column, which is this column, right? Sales price. And that's our first parameter. We're also going to give an output column. So we can do this on multiple columns, which is why we're passing in a list. In our case, we're only doing it for one. The output column needs to be a different name. So we're going to sales price imputed. And the strategy is mean. So obviously, depending on your strategy that you want to use for imputation, you can change this. And you can look in the documentation. I'll leave a link in the description below if you want to check out imputation in a bit more detail in Spark. So what we're going to do is call the fit method on this imputer object. So it's going to fit, it's going to have a look at our data in our input column. It's going to fit a model. In our case, the model is very basic because it's just the mean, but you can do more elaborate imputation methods. You could fit a model on a regression curve and use that as your imputed value. So then we've fit our model, we've transformed our data set, and we're going to show the results. So let's click that. Okay, so now we've added on this column. So all the existing data is the same, but for this null value, what's happened is it's imputed a 445360, which I assume is the mean. And for this null value, it's done the same. So that's going to be the mean of our column of the input rows. And it's just replaced all of our missing values with this mean value. Hey everybody, and welcome back. We have reached day 11 of our series exploring how to use Spark within Microsoft Fabric. And today we're coming to a very interesting topic, which is joining DataFrames. So up until this point, we've been looking at a single data, but typically in data projects, data engineering projects, we want to merge or join a few different data sets. Maybe you want to denormalize your data for your Power BI model, and you can do this at scale on large distributed data sets using Spark. And that's what we're going to be going through today. So let's jump straight into this. And as ever, this code is available on GitHub, link in the description below. To start, what we're going to be doing is reading our table. So if you've been following along with this series, you should have a table in your Lakehouse called property sales. And what I'm going to be doing is just calling spark.sql and selecting all of the rows from that table. And we're going to be storing that into a Spark data frame called sales fact df, because these are really fact tables. This is about property sales, things that have happened in the world. And so to start with, we're just going to grab this. Okay, so we have successfully grabbed our data from that Lakehouse table, and this is what it looks like. We've gone back to the streamlined 3-row data set. And we've got 3 rows and it represents different sales prices of properties. Next, what we're going to be doing is creating a dimension table, because perhaps we want to add a few more columns into this fact table with maybe more information about the agent. Okay, what company do they work for? Or the city? What country is that in? Or the type? Maybe that has a higher level categorization. So that's what we're going to be doing here. So for the purpose of the video, I'm just going to make a dimension table very quickly, and it's going to be a cities dimension table. So it's going to have 3 columns. It's going to be the city UID, unique identifier, or UID, unique identifier, the city name, and the country that city is in. We're just going to call spark.createDataFrame, and we've got our schema, which is these columns. Okay, so there you go. That's what our data frame looks like. We've got 3 columns, city name, country. And you'll notice that some of these are in our data set and some of them aren't. So we've got New York, Los Angeles, and Atlanta. We don't have London or Dublin in our fact table. So what we're going to do is join the sales fact table with the city dimension table. And I'll leave a link to the documentation that talks you through in a bit more process what the syntax is for this join function. But the generic structure of it is, okay, first we're going to get the first data frame. We're going to call .join. We're going to pass in the second data frame as our first parameter here. Then we're going to pass in as our second parameter, okay, what are we going to join on? And it's going to be similar to doing a SQL join, really. We're going to say, okay, I want the first data frame, this column, to be equal to the second data frame, this column name. And then we're going to pass in finally a join type. So this is going to be by default an inner join, but it must be one of this long list. So inner, cross, outer, full, full outer, left join, right join, semi, left semi, all of and an anti, left anti join as well. So all of these are listed here in the documentation if you want to do a bit more reading on those with some examples. But let's just look at what this looks like then. So moving on from the generic structure, what does it look like for our data? Well, we've got the sales fact table. We're going to join it on the city dimension table, that table that we've just created, this one here. And we're going to join on the city, so sales fact.city is equal to city dimension.city name. And we're going to do an inner join, and we're going to show the results. So let's just have a look at what that looks like. Okay, so we can see we've joined successfully, and we're doing an inner join. So we're getting everything from the left-hand side, basically, and the matching from the right-hand side. So we're not getting anything for Dublin or London, but where we've got New York, Los Angeles, and Atlanta, it's pulling through the relevant rows in the dimension table, which is exactly what we want. Because perhaps now we want to do an aggregate function or a group by an aggregate function on the country. So maybe we want to do country by country lists or counts of sales, for example. So that's how you would do that there. But perhaps we want to not bring over all the columns. Well, as we've seen previously, we can drop a few of the column names. Maybe I don't actually need the UID for my analysis, or the UID, I think it's called. Or we don't really need the city name because we have city already in our data set. So this is just going to be exactly the same, but we're going to call drop. Okay, so now it's exactly the same result, but we don't have city UID and we don't have the city name. And that's what that looks like there. So that's the basic way to join datasets within PySpark and within Microsoft Fabric. So very simple. That's basically all there is to it. Obviously, I haven't gone into all the details about the different join types. And if you're feeling particularly adventurous, first one to answer in the comments gets absolutely nothing but my respect and a well done. What do each of these do? So your inner, cross, outer, full. Some of these are duplicates, or just they do the same thing, but they're just called different things. Spark gives us a few different options, so bear that in mind. So if you're feeling like you've got absolutely nothing to do with your day, then you can leave me a comment with what all these do. Hey everyone, and welcome back. Today we're going to be looking at time series data. So how do we format dates, format times, conversion between strings and date time formats, which is, if you worked in a data role, this is, bread and butter stuff. We do lots of this. So this is what we're going to be looking at: date formatting, conversion, date differences, getting things like year, month, day that we love to do. Helps us with our Power BI modeling if you're going to be modeling your data in Power BI. As ever, this notebook is available in GitHub. I'll leave a link in the description. Let's jump into it. Okay, so we're going to start by generating some data. So in this instance, we're going to change our data set. You'll be glad to know, if you've been following along this series right from the beginning, we've been using the property sales data. But that data hasn't got any time, hasn't got any dates in it. So what we're going to be doing here is using this very, very basic time-based data set. Just to show you some of the functionality that exists within Spark for managing dates and time. So this is what it looks like. We've got one column, or two columns actually, and an ID and an input. And the input is just various dates in string format at the moment. And we've created a data frame from that. That's what it looks like. Okay, so let's start by doing some formatting. Firstly, we need to import some functions. So from pyspark.sql.functions, import col and date format. And this is how we're going to use these. Let me just make that a bit cleaner. So we're going to do df.select, and we're going to get the input column. So we're only interested in this column at the moment. And what we're going to do is also get the formatted version of that. And so this date format is a function that we get from this library here, obviously. And it's going to take two parameters. First one is the input column, the column that we want to format in a different way. And then the format, which is month, month, day, day, year, 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 year. So for all my American viewers, you're probably absolutely loving this, to get your date formatted into the American way of viewing dates. So let me just call df.show on this. Okay, so you can see that this string has been changed format from this very respectable year, month, day, the international ISO date time format, into this more Americanized version, which is month, day, year. We can also do lots of other date time form or date formats. Again, I'll leave a link to the documentation that kind of lists all of these, but that's how we can change that format. What I did want to show you was the print schema, because quite interestingly, what we're doing here is we're actually changing the format of a string. We haven't actually converted this to a date or a date time format, which is quite interesting how Spark does this without actually converting it to a date. Well, I think it's interesting how it does that. So bear that in mind. If you need to do some more like time intelligence based stuff, which is what we're going to move into, you're going to have to explicitly convert that column to a date type. And this is how you do that. So again, from our pyspark.sql.functions, we're going to import this new function called toDate. And as the name suggests, what we're going to be doing is, okay, first we're going to select the input column just to compare it, right? Then we're going to get this toDate function and we're going to pass in the input column and we're going to tell it the format that the input column is written in. So it's a year, month, date format. That's what the structure of the input format is, this format here. So it knows how to pass it, right? And what's interesting is when we run this and we look at the schema now, is our toDate column is called date, right? So we've called it, given it an alias of toDate, which is changing the column name. And if we look at what this looks like, well, it's going to look pretty similar. It's going to look very similar. But now we know that this input column is a string and the toDate column is of type date. So that allows us to do some more interesting stuff with it. So for example, we can do is date difference. So we can calculate the difference between two dates. So in this example here, again, we've got the input column, the input date. And what we're doing is we're getting this function here, date diff, and also current underscore date. And so we're calling date diff, we're getting the current date, and we're looking at the difference between the current date and the input column. And we're calling that column date diff. So from the 1st of February to today's date, there's 213 days, and so on and so on. So it's just a way of doing date differences. Another common operation that we do with dates and time is all this good stuff. So perhaps we want to make lots of columns or features from our data based on, okay, extracting what the year is, what the month was, what the day of the month, what the day of the week, the day of the month, the day of the year. All these good stuff is done like this. Again, very simple. We're doing a select statement. We're getting the input column as just to compare. Then we're extracting the year, like so, the month, the day of the month, which is just the day of the week, the day of the month, the day of the year. And these all come from our functions. At the top here, we have to import them like we do with everything else that we've seen so far. And so this is a very basic understanding and run through of some of the date functionality and the time series stuff that we can do within Apache Spark. Hey everyone, and welcome back. This is day 13 of our series where we're exploring how to use Spark within Microsoft Fabric. And today's a very important one, especially useful if you're coming from a SQL background. You might have lots of skills and knowledge about how to do complex SQL queries. And the good news is that you can use this knowledge within Spark. And today we're going to be showing you exactly how to do that. So the title might be a little bit misleading to some because up until this point, we've actually been using the Spark SQL API, which is where the DataFrames that we've been using comes from. But specifically today, I want to talk about this kind of construct that we haven't done much on before, and that's the spark.sql. Now we have used it for getting data from a Lakehouse table, right? So you remember if you drag this table into the canvas, into the notebook, we're going to get this auto-generated Spark SQL statement. Select star, get me all the columns from this Lakehouse and this table specifically. And it's going to by default give you a limit of 1,000. So that's an example of a SQL statement that we've run on our table. And that's what this looks like here. But we can also do more than just a simple select statement. In fact, we can do pretty much anything that you want to do that you can do in SQL. And we can just pass in this SQL query string into this spark.sql function. And it's going to act like a SQL statement. And it's going to give us the results in a data frame for any of the kind of normal SQL functions or SQL query statements that you would use. For example, let's go into something a bit more advanced. So the first one, we were just doing a select star. But this is just to show you that we can actually also run other SQL statements. So you could do a select. Here I'm concatenating, and let me just run this one first, just to show you what this data looks like. Okay, so this is what our data set looks like. We've got 5 columns, 3 rows, data about property sales in United States. So what if I wanted to maybe merge some of these columns? And by merge, I mean concatenate, not merge. And I can run that, and I know how to do that in SQL. Well, what I can do is just run spark.sql and pass in the SQL statement. So what I've got here is a concat, and I'm concatenating the address and the city with a comma in the middle, and creating an alias for that column name. I'm saying, okay, call the column name full address. And I'm also getting the type column, which is another column here, from our database. And here I'm using a where statement, right? So previously you might have seen I did a video on DataFrame filtering. Well, we can actually, if we know SQL, we can just embed the script here. And you're probably hating me for not telling you this earlier, but it's good to know both ways of doing it because both have their merits. So if you're strong at SQL, you can just write where type Lakehouse, which is going to return all of the values that contain somewhere this string house, because we've got the 2% sign at the beginning and at the end of the string. So it's going to say, I don't care what's before it, I don't care what's after it, but it needs to have house in there somewhere. So this is what we get, and we get a data frame returned. I've just displayed it here. We've got the concatenation, our full address, which is the single address concatenated with the city, which is what we wanted. And we're filtering using this SQL where statement, only the houses. So that's quite interesting and quite useful. So then you start to think, okay, so why wouldn't I just do that in SQL? Fair enough. I've got a whole data warehouse. Maybe I can just create a shortcut and I can just write SQL. What's the point in doing this in Spark? Well, we can start to layer in some interesting ways of working with this now, because previously we're just giving kind of hard coding this statement. But what if we wanted to do something a bit more dynamic? Well, we can start to do here. What I'm doing is I've created an F string. So if you put F in front of your string in Python, you can pass in variables into your string. So here it's not really highlighted very well in the kind of the formatting of the cell. But if you can see these curly brackets here, what I'm doing is I'm passing in a limit variable. And the limit I've defined in this list, I've got a few different limits. Now this is just a kind of toy example to show you how we can do dynamic SQL. And I'm saying, okay, for each of the limit in limits, so 1, 2, 3, 4, grab this statement, assign it to a data frame, and show me that data frame. So what this is going to do is going to loop through 3 times, because we've got 3 values in our limits list. And first we're going to get 1 row, then we're going to get 2 rows, and then we're going to get 3 rows. Now again, this is just to show you the functionality. Like this specific example is useless, but we can see we've got 1 row, 2 row, 3 rows. But the idea behind it is quite powerful, because we might not care about limits. In fact, no one cares about limits. It's just to showcase the functionality. What we might want to do is have a list of table names. So maybe we want to iterate through lots of tables. We've got 100 tables in our Lakehouse. And we create a list of these tables. And we iterate through these tables, injecting the table name into this SQL statement, grabbing our data, and then doing something useful with it. creating some statistics, feature engineering, or this whatever you want to do with your data. Do something more useful, not just showing it. So I hope you're beginning to understand kind of the power that we can get by combining SQL, our SQL knowledge, with Python and Spark. And we can kind of iterate between the two. Now, one other SQL-like functionality that we get with Spark is temporary views. So again, we're going to read in our data frame. We're going to refresh that because we've been playing around with it a little bit here. And we're going to call this function, and it's create or replace temp view. And what this is going to do is create a view, and this kind of persists for the duration of our session. So it's really useful if we want to kind of store a temporary view. It's a bit like a temporary table in SQL world. And we give it a name, so we've called it sales fact. And so if we don't want to use data frames, we can use these temporary views. And the way that we can use this or reference this in future SQL statements, right? So we can say spark.sql select star from sales fact. And we can do other stuff in the SQL world before bringing it back into the Python world and saving it to a table. So it's just another way of working with SQL and Python in Spark. So again, what we're doing here is obviously we've saved our temporary view called sales fact, and we're just selecting it. Just to give you a bit of a few different ways of working with SQL and Python combined. Hey everyone, and welcome back. And in today's video, I've got a very, very special one for you because we're going to be deep diving into the world of machine learning in Spark. So if you've been following this series, you'll know that actually I was supposed to deliver a video 2 days ago and yesterday and today, all on the topic of machine learning in Spark, but I was a bit busy this week. So what I'm going to be doing is producing one end-to-end video about everything you need to know about Spark and machine learning, because there's quite a lot of stuff in there. So what I wanted to do in this video is to provide an overview of all the different components that are available to us out the box with Spark in terms of machine learning. Then in the second half of the video, we're going to be building a sentiment analysis machine learning model that's going to be able to predict the sentiment of tweets. So I'll show you how to kind of string together various components within the Spark ML library. And yeah, that's going to be really fun. So first things first, this video is more aimed at people who have done a bit of machine learning in the past. So I'm not going to spend too much time talking through the different concepts in machine learning. Otherwise, I'd probably be here all day. There's a lot of background knowledge in machine learning. It's more for people that have used machine learning in other libraries, within Python, maybe scikit-learn, or maybe you've done some like neural network stuff in TensorFlow or PyTorch or something like that. The purpose of this video is to show you how to do distributed machine learning in Spark. We're going to be using the machine learning part of Spark that deals with DataFrames, which is specifically Spark ML. So if you go into the documentation, we can just start by reviewing what's in here. Okay, so on the top here, you've got the ML lib, the main guide, as it's called. So this is the kind of the standard currently for machine learning in Spark, and it's based upon the data frame. So that's why we've spent the last 2 weeks learning all about the data frame, okay? How to manipulate it, how to do various operations with the data frame. But previously, up until I think Spark 1.3, there was this object called the RDD, and the old RDD was this abstraction or object that was kind of like the core of Spark. It's a resilient distributed data set. Now that's kind of been superseded to a certain extent by the data frame. So the data frame is kind of like the first class citizen now in Spark, and that's what you do everything with. So if you're navigating the documentation, just bear that in mind. We're only really interested, for the purpose of this video, in the main guide, which is this top one. So the library is split into a few different sections within the library. At the beginning of every machine learning project, you're going to be wanting to do some feature extraction and feature engineering. So there's a whole class of tools available to us for creating features from our data, whether that be text data or image data or basically any data that you want to throw at your machine learning algorithm. Then we've got some machine learning models, so classification and regression models. We've got clustering library. There's some stuff if you want to do collaborative filtering. And there's also frequent pattern mining. I've never actually used that. And there's model selection and hyperparameter tuning. So there's functionality built into Spark to help us do that. In this video, we're going to be doing some feature engineering, and then we're going to be training a machine learning model, logistic regression, which is a binary classification model. We're going to be evaluating the results and visualizing it a little bit. And we're going to be doing all of that within a pipeline. So throughout the course of this video, you're going to be learning quite a lot of the Spark API for machine learning. So let's dive into it. This is the data set that we're going to be using, and I just found it on Kaggle. I'm not sure of the quality of this data, but it's good enough to help us learn a bit about how Spark works in terms of machine learning. It's a very simple data set. We've got a collection of tweets. I think there's about 6,000 or 7,000 in total, so it's not a huge amount, but a bit more than we're used to dealing with in the last few videos. It's a very simple binary classification data set. We've got a tweet in one column, and we've got a sentiment, which is our label of 0 or 1. And in this case, 1 stands for a negative tweet, and 0 stands for a positive tweet. So this is an example of the data. And I'll leave a link to this below if you want to do this in your own Fabric environment. So it's very simple. We've got ID, label, tweet. So what I've done is downloaded this data set. So we've got that as a CSV. And as with all the other ones, I've uploaded this into a files location in our Lakehouse, just called it sentimentanalysis.csv. So let's get going. We've gone through the introduction to the task, and you know all about that. So we're going to skip that now. Okay, so the first thing we're going to be focusing on is reading in the data and performing our training testing split. And so hopefully none of this will be new to you. We've got the DDL, data definition language schema, and we're passing that into the read CSV function, which we've used quite a lot. And then we're going to display the first 3 rows just to check that it's working. And we've got have a quick look at the data. And then we're doing this train test split, right? So this is not actually it's a DataFrame function that we have available to us. It's not necessarily part of the ML library, but what we can do is do a random split. And we pass in a seed, a random seed, and an array of our split. So in our case, we're just going to do an 80-20 split. So 80% will be training data, 20% will be reserved for our testing. So let's just run this. Okay, so that has now run. And we can see that this is the structure of the data set. We've got a data frame with an ID column, our label, which is 1 or 0, and then we've got some tweets. So they're a bit messy, these tweets, but that's the nature of natural language and tweets in particular. But it just gives you an idea of what these tweets look like, what our data looks like. And I've also printed here the training data count and the test data count. So we've got about 6,000 rows in our training data set. Not particularly big, but it's okay for this exercise. We're just showing you the functionality. And then we've got the test data, which is around 1,600. Okay, so we've got some data. What are we going to do with that? So what I've done is I've put everything together into one pipeline, and we can spend a bit of time walking through what these steps in the pipeline does. It's just I've picked a few feature engineering transformers or functions that help us to understand how it works, how you do feature engineering, how you can string these together in a pipeline, and then how you can train a model at the end of it. There's some basic concepts to learn in Spark, specifically in the machine learning section of Spark. So if we drop back to the documentation, okay, so if we go to the pipelines section of the documentation, it tells us about some of the core concepts in pipelines, or more generally in machine learning in Spark. So we've got our data frame. We know that, we've seen that quite a lot of times already. But here it's introducing a new concept called the transformer. And as it says here, it's an algorithm that transforms one data frame into another. And in that process, it's going to transform that data frame in some way. So depending on, and this is typically used for feature engineering, right? So we're going to pass in our raw data. We're going to perform some feature engineering, and it's going to output another data frame, normally with the input data frame plus some new features, depending on what feature engineering step we want to give it. We've also got an estimator, which is an algorithm that can be fit on the data frame to produce a transformer. Okay, so for example, a learning algorithm is an estimator. So a transformer typically has the function .transform, and the estimator typically has the function .fit. And we're going to see what that means in a minute. And the pipeline simply chains together transformers and estimators, right? To allow us to kind of build a bit of a pipeline. So we start with raw data, have a few feature engineering steps, and then at the end we have an estimator. And then we have the parameter. So all transformers and estimators share a common API for parameters. And this is important if we want to do anything like hyperparameter optimization. And we'll look at that, or at least point you to the correct section of the documentation. We're not going to be doing hyperparameter optimization, hyperparameter tuning in this video. But just know that within pipelines, the parameter is kind of like a common API. So all of our feature engineering steps and our model, all of the parameters that you input here, can be accessed via a common API so that we can do hyperparameter tuning very simply. Okay, so that's enough about that. Let's go into some of the feature engineering. So what features do we have for feature engineering? Well, feature engineering in Spark is split into three kind of subgroups. So we have feature extractors. So these are going to be extracting raw features from raw data. Okay, so TF-IDF, term frequency, inverse document frequency, word to vec, count vectorizer, and a feature hasher. So these are some of the feature extraction methods that we have available to us. Then we have feature transformers, which typically take these raw features and make some other features from them. So here you've got tokenization, stop word removal, binarizer, PCA, principal component analysis, string indexing, one-hot encoding, scaling, normalization, all these kind of core feature engineering steps that you might want to do in a machine learning pipeline. Finally, we have some feature selectors. So it's going to take your set of features and input columns and reduce the dimensionality somewhat by selecting various features using different methods. So you've got chi-squared selector, univariate feature selector, and so on. Now, there's some other stuff for LSH, locality sensitive hashing. Not going to go into that in this video. So let's just look at our data. So we have some tweets, and what I'm going to do is I'm going to build a bit of a feature engineering pipeline to transform our raw tweet into something that our machine learning algorithm can consume. Because most machine learning algorithms, they don't accept text as an input, right? You have to do something with it. For most machine learning algorithms, they expect numbers and vectors. That's kind of how they operate. So we need to transform our raw data from text, from tweets, into some encoding of vectors. Now, this is kind of right at the heart of feature engineering. And ideally, we want to do that encoding of these words to vectors in a way that's sympathetic to the problem that we're solving. This is quite a naive approach that I'm showing here because it's just tokenization, TF-IDF, which is okay, but it's not necessarily going to give us a really good machine learning output. It's quite a naive solution because if you understand what TF-IDF is, all we're doing here is counting the frequency of each term and then looking in the rest of the corpus or the rest of that column that we've got and seeing how rare is each word. Is this really giving us much information? So it's not really telling us much about the sentiment. Might have some impact, the TF-IDF, on the sentiment, but we're not really doing proper sentiment analysis feature engineering. But it's just for this example. So let's go into this in a bit more detail. So we've got the tokenizer, right? And the generic structure here, we're going to import it from pyspark.ml.feature. And we've imported three different objects here. So we've got the tokenizer, the hashing TF, and the IDF, because we want to do TF-IDF. That's the plan here. So we're going to initialize our tokenizer. And what we're going to do is give it an input column and an output column. Now the input column is going to be tweet. So we're going to start here. And you're going to see that the output column is words. And then for each step in our feature engineering pipeline, we're kind of going to chain these together, right? So you have to make sure that the output column of your tokenizer matches up with the input column of our hashing TF, okay? So we're going to start by doing some tokenization. So we're going to split our tweets into a list of tokens, a list of words, basically. The next step is going to be this hashing TF, which is going to map a sequence of words to their term frequency. So how many times does that word appear, okay? Next, and this is going to output raw features, okay? And this is one of our parameters. We're giving it a number of features. That's basically the hashing space that we're mapping to, is 20. So IDF next, and the IDF, as I've mentioned here, is basically how rare is that term? How much information is that term giving us for our prediction? And so it's going to take the raw features from our hashing TF, and it's going to output some features. And what you can do is, because this is a transformer, so we can actually, if we wanted to just test this, you can actually break down each individual step and have a look at it. So if we do token data, if we do token data dot tokenizer, and we call this dot transform on it, and we pass in some data. So we got training data, because we've already done that from this train test split. We've got our training data. So what we can do is this, and then we can just have a look. And so if you're looking for a bit of a blow-by-blow account of what this data looks like as it passes through the pipeline, you can kind of add a new cell and just have a look at what this looks like, really. So if I run this, you're going to see this is what it looks like. So we've got our tweet. Our original data frame, basically, is the first 3. And then it's put this output column of words. So that's not a very good example. But so the input tweet was what amazing service. Apple won't even talk to me about this question, and it's just creating this list of tokens, okay? So what amazing service. So it's like the first step in our pipeline. So we've initialized our 3 feature engineering steps, okay? But we haven't transformed them yet. We don't need to transform them if we're going to use this pipeline. So along this bottom row here, what I've done is initialize a pipeline. So we're doing from spark.ml import pipeline, and I'll go back to the logistic regression model in a second. But we've defined a list of stages in our pipeline. We pass in these stages. So we're saying, okay, I'm going to start with a tokenizer, then I'm going to do some hashing, term frequency hashing, calculate the inverse document frequency, and the final one is this logistic regression model. So here, to initialize this logistic regression model, if you've used scikit-learn or anything like that, it's very similar. Here we're just reading from the pyspark.ml.classification library, importing logistic regression, passing in these hyperparameters, and I've just hard-coded them in this instance. We're not going to be doing hyperparameter tuning in this example, but I can show you how to do that afterwards. So it's just a very basic setup of a logistic regression model. So when we construct our pipeline, the final step is to call .fit. Our training data is going to pass through each feature engineering step. Then it's going to fit this logistic regression model to our final features, okay, in our training data. And so that's going to finish with this LR_pipeline. So that's great. We've got a trained model. How do we actually test that? There's a few ways to do evaluation in PySpark. This is one of them. So ultimately what we want to do, our logistic regression model, because we've passed in this logistic regression model, it's going to return a transformer. So we can call .transform. And what that's going to do is do predictions on our test data, okay? So our prediction is going to basically look like this, and we're going to be able to select the label and the prediction. And one method of evaluating our results is to convert this into an RDD and then use binary classification metrics. So here we're going to print out the area under the rock curve, the receiver operating characteristic curve, and then we're actually going to use matplotlib to visualize the ROC curve. So let's just do that. Got to train the pipeline first. That would be useful. Okay, so that has now run. Next, let's run this model evaluation. Okay, so we've got our area under our ROC curve, which is 72.7, so 73% accuracy. And you can see that we've got this ROC curve. Basically, if you're a data scientist or you've done machine learning before, basically what we want from this curve is a line that's as close as possible to this top left-hand corner, right? So we're going to want a very high true positive rate and a very low false positive rate. In our case, we've got 73%. So it's not great because it's a binary classification model. If you chose 0 for every prediction, you'd get 50% roughly. So this isn't too great, but kind of shows the fact that we've used quite naive methods for feature engineering, just to show you the functionality of Spark. If this was a real life project, you'd want to do a lot more interesting features to kind of explain the data in much better ways. So there you go. Now we've seen, in a very quick amount of time, we've seen some of the core aspects of Spark machine learning. So we've looked at feature engineering, we've trained a model, and we've evaluated that model. One thing that I didn't mention, if we go back to our documentation, there's also functionality for hyperparameter optimization, more advanced things like cross-validation. If you want to do like k-fold cross-validation, that's also an option here. And this is the documentation for that. It's fairly simple. You can just set up this param grid and you pass in a number of parameters that you want to optimize over. So for example, our hashing TF, the number of features, I think we gave it 20. You can pass in a list of parameters and it'll kind of do a grid search through those. Again, the cross-validation is simple. You pass in the param grid and then it's basically going to split your data into k folds, depending on how many folds you give it here. So normally 3 or 5. Yeah, it's going to split up your data into 5 and then test and train on each of your 5 folds. Okay, so it's obviously going to take a lot longer, but you're going to get better results. The other thing to mention is this tutorial is focused mainly on the machine learning capabilities within Spark. Now you can also use Synapse ML, which is the Microsoft open source library for doing distributed machine learning on Spark. And that's another option, but I haven't gone into that in detail in this video. One also thing that I haven't mentioned in this video is how to productionize your model. So let's say we're really happy with this pipeline and this logistic regression model. There is actually functionality built into Fabric for saving our machine learning models and then serving them in production. So in this video, I haven't actually gone into that, but perhaps if you're interested in seeing that functionality, then I can show that in a future video. So if that's something that interests you, let me know in the comments. Hey everybody, and welcome back for another video. Today we're going to be looking at how we can customize the configuration of Spark within Microsoft Fabric. So up until this point, we've really been getting our hands dirty, really, in Spark, doing operations on DataFrames, learning about how to manipulate, clean data, all of that good stuff. And last time we looked at machine learning in Spark. But in this video, I wanted to step backwards a little bit and think about how we manage Spark within Microsoft Fabric. For maybe 90% of people, you probably won't actually have to do any custom configuration of Spark. The defaults are probably good enough for what you want to do with it. But for the other kind of 10-20%, typically those with more demanding resource heavy workloads that they want to be running on Spark, it's really important to know how to customize Spark to use it to our advantage. So in this video, I'm going to be talking you through first the overview of kind of the environment in which Spark works in. And once we understand that environment, we'll then look at how we can customize it for different workloads. And in the second part of the video, I'll be diving into Fabric and I'll be showing you how to do these customizations within Microsoft Fabric. So I'm going to start off by introducing you to the Fabric Runtime 1.1 or version 1.1. So if you're wondering what is a Fabric runtime, then you might see this in the documentation, but it's basically the environment in which Fabric notebooks, so your data science and your data engineering experience, all work on top of. And our Fabric runtime comprises of different layers of technology. A lot of them are open source technologies. And once we understand what these are, then again, we can understand how to configure them for our advantage depending on what we want to do in Fabric. So firstly, we need to understand that the Fabric runtime, or the environment that our Fabric notebooks works on, is built on top of Ubuntu 18.04. This you can't actually change. There's no way of changing this. Obviously, this is a software as a service solution, so I don't think you can change the underlying operating system which our notebooks run on. So on top of this, we have the storage layer, which is built on top of Data Lake, and specifically Data Lake 2.2. So Data Lake, as you may be familiar, is an open source technology for managing Delta tables. The One Lake is built on top of this Delta Lake technology stack. So on top of the Ubuntu operating system, there are 4 different languages installed. We've seen this already, right? Or we've talked about it at least in the Spark world: Java, Scala, Python, and R. So these are kind of the 4 languages. So Spark itself is written on top of the JVM, so the Java virtual machine. And Python and R are a bit different, so they're more high-level languages, and these are compiled down to the JVM. That allows us to write Python that's then compiled into something that the JVM can understand. With each of these, we have a set of default libraries given to us in Microsoft Fabric, and I think for the Python default libraries, it's the Anaconda. So if you're used to the Anaconda distribution of Python, then all of the libraries that you get with that Anaconda distribution will be installed as default. But on top of the default libraries, we can also add our own. So I'll be going into this in a future video, and I think I've mentioned it in one of the previous videos, but we can use PyPI, the Python kind of package manager, as well as conda install as well, to install any additional libraries that we need. We can also install packages from wheel files, custom packages that you've created yourself, and we'll look at that as well in a future video. So on top of this, we have Spark. So out the box, the Fabric Runtime 1.1 ships with Spark 3.3. So there's lots of versions of Spark. It's an open source technology, and it's always being revised and updated. So if you get Fabric Runtime 1.1, it'll come with Spark version 3.3.1. And obviously, as you get different versions of Spark, you have different functionality. They're always bringing out new features, new optimizations, and there is the ability to change this version of Spark in Fabric if you want to install a different version of Spark. For most people, they're just happy with Spark 3.3, the version that comes with Fabric, and that will be good enough for your workloads. So on top of Spark, that's where we have our Fabric data engineering and our data science experiences. So this is where you kind of interact with, right? You interact with a notebook, you write your code in a notebook, and in the data science experience, you might convert these into experiments, train some models, that kind of thing. This is kind of the runtime stack, as I would call it, and we get all of this kind of built ready for us to do whatever we want. So we have specific versions of Delta Lake and Spark all wrapped up into this bundle with Ubuntu operating system, so that by the time you or the user comes to Fabric and they just open up a notebook, all of this is already included, right? It's kind of, you get the default settings for all of these things and you can go about your business. So in terms of the administration and customization and optimization options, let's just squeeze that diagram up a little bit, and I'm going to talk to you a little bit about what we can do here to kind of customize this configuration. Well, the big one is in Spark. So there's lots of ways in which we can customize Spark to do different things depending on our use case. We'll be going into these in a bit more detail in a minute, but we can define custom pools, and we'll talk about what that means a bit later on. We can also tell Fabric or Spark via Fabric what the size of the nodes we want in our configuration, how many nodes we want, the capacity of those nodes in the configuration. And we can also do things within notebooks like auto-tuning and also auto-scaling, right? So depending on the workload, it will dynamically allocate different resources depending on what needs more resources. We've also got in terms of scheduling our workloads in Spark, they've got built-in functionality for that, which is Spark jobs. And I'll be going into that in more detail in a future video in this series. So we've talked about library management, and that's going to be another video in this series, how we can manage libraries in our workspaces and how we can add custom libraries and all that good stuff as well. So concurrency is another option or thing to consider when we're working with Spark, especially at a very large scale, right? So if you're working with terabytes of data every day and you've got high throughput of data, then concurrency is something you're going to want to consider, or you're probably considering it already, but you want to know how to do that within Fabric. That is, again, worthy of another video, so I'll be talking about that in a future video as well. We've also got the MSSparkUtils functionalities that I'll be going through again in another video, and also monitoring Spark. So these are another thing you need to bear in mind if you're administering Spark in Microsoft Fabric. How do we do that? And another future video that I'll be working on is the Scala and R. So for most of this series, we've been working in Python, but as you can see here on the diagram, you can also work in Scala and R, and I'll be looking at how to do that if that's your preference, and coming at some of the pros and cons of each of these. So that's it for the kind of the slides section of this video. Let's jump into Fabric and look at what all that means in context. Okay, so here we are. We are in our data engineering experience. Actually, we're in our workspace. We've got Spark September, which is our workspace that we've been working in all throughout this series. So let's look at how or what we can do to configure and manage Spark in here. So the first thing to look at is the workspace settings. And if we go down to data engineering, data science, you can see there's two options here. We've got Spark Compute and library management. So obviously library management is where we're going to go to import and install custom libraries or packages from PyPI, the Python package manager. And we've looked at this previously, and I'll be doing a video on how we can manage our libraries in a good way in Fabric in future. But what I want to focus on today is Spark Compute. So we're going to look at what we can do to manage our Spark Compute. So you'll see here at the top, you've got the default pool for the workspace. So by default, you'll have this starter pool. So a good place to look to understand the starter pool is over in the documentation. So if we go to this, and I'll leave a link in the description, it's basically the overview of Spark Compute. And a starter pool is basically a pool with this configuration. So the node family is memory optimized, and we'll look at what that means later. We've got the node size is medium, and the max and min of the nodes is, well, the max is 10 basically. So one of the benefits of these starter pools is that they are very fast and easy way to get up and running with Spark in your notebooks, right? So traditionally it would take about 3 or 4 minutes from the time you start your Spark session to getting an output from your code, right? It takes 3 or 4 minutes to start up a Spark session, get going, get all these cogs moving behind the scenes. And 3 or 4 minutes is quite a long time. If you're doing an hourly job, for example, an hourly kind of Spark job, it's going to take a while for that to get up and running. So what starter pools introduces is this concept that, it's always on. These starter pools are always on, but you don't necessarily pay for it when you're not using it. So as it says here, the starter pools are always on and ready for your requests. And they dynamically scale up depending on your need. And it's important to note about the billing cycle here, because if they're always on, you might be thinking, okay, this is going to cost me a lot of money. But in terms of these starter pools, when it's initially started up, you don't get billed anything. It's only when your pool is running, when you're running code on it, then you're getting billed. When it's stopping, you're going to be billed during that process as well. But then when it stops, you're not going to get billed as well. So this is a really kind of positive move, I think, in terms of optimizing how much money you're going to be spending on Spark, but not necessarily money, but it's going to come out of your capacity allowance, right? So this is a really important thing to note. So this is the default. What we can also do is create custom pools. So if we're not happy with that configuration, the starter pool, well, then what we can do is create a new pool. So if we click here on starter pool, this is the default. You can also add these workspace pools. And you can see I've already created one there called single node mode. and we'll go into that in a minute. But if I click on new pool here, it's going to allow me to configure a new pool. If we give it a name, my new pool, there's a few configuration options here. So the node family we can't actually change. The node size is something we can change. So as we mentioned, I think in one of the early videos in this series, Spark works by distributing your compute across multiple nodes. So multiple kind of individual servers, and then it combines the results and serves them back to you in your notebook. So our node size is going to tell us how much compute we have on individual nodes. So obviously a very small node is going to be a small level of compute, and XX large nodes is going to be capable of really high levels of throughput and compute on really big data sets. Auto scale is, as the name suggests, it allows you to scale up or down based on the amount of activity, so on the amount of data that you're crunching or in the amount of throughput that you've got in your system. And then when that computation is finished, it will scale back down. If we don't need that much compute, it will go back down to whatever you set the minimum to be. So another thing we can do to customize the configuration of our Spark pools is to change this setting, which is dynamically allocate executors. And the executor sits on the worker node, basically. So the worker node is the nodes that are kind of doing the work in our Spark configuration. By dynamically allocating executors, what this means is it's going to help us work more in parallel. And we'll go into concurrency in a future video, but this kind of allows us, again, more throughput and more data to be computed over in our clusters. Again, it's going to cost you more compute, right? It's going to use up more of your capacity, more of your credits. Another thing to mention is this single node mode. So I haven't created that one here, but let's talk through what I've created here, which is another custom pool that I've created. So if we click on an existing one, we can click on this little pencil icon here, and we can look at this existing configuration. And so what I've done is created a new pool called single node mode, and it's memory optimized, and the node size is medium. But in this one, we've defined that our maximum number of nodes is going to be 1. So it's only going to run one node, which is basically like computing on your own computer. We're not going to be able to do distributed anything on this configuration, but it's going to be very cheap. It's not going to use many of our capacity units, right? And it's also going to allow us to use like single node libraries like matplotlib very easily, like TensorFlow or scikit-learn, any of your kind of traditional Python packages. Maybe you're used to working on Python on your local machine. This is going to be a very similar experience, right? Okay, so another piece of configuration that we can do is obviously to change the runtime version. And currently there's only one runtime version, which is what we've been discussing in our slides earlier. We can also change concurrency. So whether we want high concurrency to be on or off. So how parallel do we want to do our jobs, right? So when high concurrency is on, multiple notebooks can use the same Spark application to reduce the start time of each session. And we can turn that on or off. And again, I'll be doing a video on concurrency a bit later on. We can also change whether we track automatically machine learning models and our experiments, so on or off. And we can also define Spark properties. So you can define a lot of custom properties for our Spark configuration, and there's hundreds of them. So for most users, you probably won't need to do this, but if you're doing more advanced Spark use cases, then you can set specific properties for your Spark instance here. Now, the final thing to bear in mind is that up until this point, I've been working in the workspace settings. I'm configuring the Spark instance for this one workspace. What we can also do if we go out of that is go at a higher level. We can go to the admin portal and we can look at our capacity settings. So we can also update our Spark configuration at a capacity level rather than just a workspace level. So that's something to bear in mind. So for example, here I'm going to go to I'm using the trial currently, the 60-day free trial that's lasted 4 months so far. So thanks for that, Microsoft. And we go to data engineering, open Spark compute. But currently, I think because I'm using the trial capacity, it's not allowing me to do any sort of configuration changes. I think once you pay for Fabric, then, and you're not just using the trial configuration, you can go back here and you can go to Fabric capacity and you can control your performance and scale from there. Hey everyone, and welcome back for another video. Today we're going to be looking at the auto-tuning our Spark configurations in Microsoft Fabric. So in the last video I went into a bit of detail about how you can manually configure your Spark runtime, your Fabric runtime, everything to do with Spark basically. The node sizing you want, the auto-scaling functionality. And if that was a little bit overwhelming for you, maybe you're coming from a Power BI background or a SQL background, and you think, I don't want to have to worry about all that, then the good news is you don't. Or at least you probably won't have to, because Microsoft have introduced this auto-tuning functionality. Let's just start by looking at the documentation and we can begin to understand what it's actually doing here. So if you want more of a hands-off approach to managing your Spark configuration, you want to trust that Microsoft machine learning algorithms can tune your Spark configuration better than you can yourself, then this is the tool for you. And it says here, I'm just going to read from the documentation so we just have an understanding of what this thing is. So Auto-Tune automatically tunes Apache Spark configurations to minimize the workload execution time. So if you've got some really long running jobs, maybe you're training machine learning models, or you're doing very heavy calculations, typically, especially join operations on very large data sets, then this is going to be a really good tool for you. And let's just understand what it's going to do. Is it's going to have a look at your historical runs, so you have to run it a few times, your problem query, let's say. Then what it's going to do is it's going to have a look at kind of the execution and the jobs and the tasks in that workload that you've been submitting historically, and it's going to optimize your Spark configuration to perform that workload more efficiently. So what's it actually doing? So we've got three things here that it's going to be optimizing. It's the number of partitions that you've got for join and aggregates, basically. And then it's the join threshold. So a lot of these parameters you notice are around joining. And we did a video actually on joining. I can link to that above. And we didn't mention so much about the kind of the performance implications of joining. Now this is particularly important on distributed data. Now, if you're used to working in SQL, then joins are generally an expensive operation that you have to kind of be careful of. But that's even more so the case when your data is distributed across different nodes, right? Because it has to understand how to join across different nodes. And generally it's even more computationally expensive than it would be if everything was in one node. So it makes sense that this kind of auto-tuning is auto-tuning parameters that are specifically important for join operations. So the final one is this max partition bytes. So this one is about when you're reading files, it's basically the maximum size of each partition, the number of bytes that you can cram into each partition. And so that's going to help with kind of file loading times from raw data into Spark DataFrames. So these are the three things that it can affect. Let's have a look at how to implement it. So it's very simple. I've just got a blank notebook here, but normally you'd want to do this in a notebook with your computation. And we can start by making that cell a SQL cell, or you can left click here, just click on Spark SQL so that Fabric knows that you're giving it a SQL command. We're going to access this parameter here, which is spark.ms.autotune.querytuning.enable. And we're going to set that to true. So if we just do that, and so there you go. It's as simple as that. Now the next time that your workbook runs, it's going to try and optimize the configuration of Spark to make that workload run even quicker. So what are some of the benefits of this? Well, obviously there's going to be benefits and use cases for saving you time and money. It's going to use less resources if you have a more efficient configuration of Spark for this specific workload. It also means that you're not going to have to be doing that manual configuration of your Spark environment yourself. And if you're not an expert in Spark, that might be a little bit overwhelming. So this auto-tuning functionality is really good for you because you can just set that to true and you can leave it in the hands of Microsoft to update that configuration automatically. So if you're a bit curious about how that actually works, then if you flick over to the documentation, it gives a bit of an explanation about how they do this auto-tuning. So it's basically a machine learning problem. They have historical data about all of your run statistics and the workload statistics and all of the configuration settings that you have in a historical basis. And then they're just going to do an optimization. And so they have a trained machine learning model and they are basically looking for the shortest predicted execution time. So they run this machine learning algorithm, they predict it on your specific workload, and it's going to return an optimal set of configuration settings, and it's going to automatically set those to whatever the output of the model is. That's kind of like the overview of what this ML model is doing here. So that's basically it. Very simple, just a quick way to auto-tune your Spark configurations if you don't want to be getting your hands dirty in the back end of configuring Spark. It's just one line of code, and that should make your notebooks run quicker and save you capacity units in the long run. Thanks very much for watching. See you tomorrow. Hey everyone, and welcome back. And today we're going to be looking at library management. How do we manage Python packages in our Fabric notebooks when we want to do data engineering, data science in Microsoft Fabric? There's many ways of doing this, and I'm going to be walking through some of them and the pros and cons of each method, just so you can understand which one is best for you in your specific use case that you want to carry out in your organization. Okay, so here we are in a notebook, and the first method that we're going to look at for installing Python packages in kind of our workbook notebook environment is inline. So you're probably aware, if you've used IPython notebooks before, that you can use a few commands to install packages within the notebook itself. So one example would be something like this. So if you use the exclamation mark, what that's going to do is install that library inline, but it's going to, in this Spark environment, it's only going to install it on the driver node, not on any of the executors, the workers. So that's something to bear in mind there. So if you want to install packages on the driver and all of the worker nodes, then you can do it like this, just with a single percentage sign plus pip install altair and your package name. So that's how you would do that inline to get a package on your driver and all of your executor nodes. So this is useful for when we're doing like work in progress stuff. We're just playing around a bit. We're just like not really caring much about maintainability. It's just getting that library into our notebook environment very quickly so that we can do some script or play around a bit. Now, what you do have to bear in mind though is that when you close this Spark session, that library is just going to go away. So if you open up another notebook and another session, that Altair library is not going to be available to you. So if you set up a data pipeline, for example, and it doesn't have this cell in here and you're triggering the execution of that notebook within the pipeline, it's not going to recognize that package, so it's going to fail. So that's kind of inline package management or installing packages. The other way that we've looked at previously, but I'm just going to go over again, is to use library management. So let's flick over back to our workspace and explore what this looks like. So if we go to our workspace here, and if I click on these three buttons and workspace settings, so you can see here you've got the data engineering, data science, library management. So this is where we're going to be managing all of our libraries centrally. Now this is a much better idea for organizations to manage all of your libraries in this library management tool, because number one, you can ensure that everyone who's working in that workspace is using the same set of packages, they're at the same versions crucially, and they're going to be updated at the same frequency for everyone working in that workspace. It's very easy to add new libraries, so probably the main way is to get it from PyPI, which is the Python package manager. So here you just type in the name of the library that you want, for example, Altair, and by default you can have the latest version, but you can also select a specific version in the past that you want to always download this library at, so that's very useful as well. And then once we click apply, I'm just going to use 5.1.1. Then when we click apply, that's going to install it onto our kind of base configuration of Spark, so that every time you start a notebook, that library is going to be available to you every time. You don't have to install it. So there's a few other ways that we can add packages. So if I just delete this, so there's also from Conda. So Conda also has its own kind of package management way of installing Python packages outside the base Conda distribution. We can also add custom libraries, so we can upload files, right? So for example, here I've got a wheel file, a WHL wheel file, which is a Python representation of a package, but it's just a kind of exportable Python package. So if I apply that, that's another way that we can bring in custom libraries into our environment, right? And then it's going to take a few minutes to install these in your environment, but then once it's up and running, you don't have to do anything else. It's just there available to you every time you want to use Fabric in this workspace. Hey everyone, welcome back, and in this video we're going to be talking about running multiple notebooks concurrently, so at the same time. Before we dive into what high concurrency mode is in Microsoft Fabric, I think it's best to start off with a bit of an example as to showcase the need for this or demonstrate why this is important. So if you can imagine that you have your Spark session, and on this Spark session you're running a notebook. Maybe you're training a machine learning model, or you're doing some really complex data engineering run, and it might take 10, 15, 20 minutes, maybe up to 30 minutes to do this run. Well, what you don't want to do is allow that to kind of cripple your productivity and mean like, well, if that Spark session is being used, then I can't use it to do any other tasks in another notebook. Well, what high concurrency mode solves, it allows you to run multiple notebooks at the same time using the same Spark session, right? So we can run our long-running training of a machine learning model, for example, and then we can open up other notebooks and we can do other stuff on that, and the Spark capacity is going to share resources for each of your notebooks. There's not going to be any starvation of resources. It's going to be shared between them. So that's a little bit about what high concurrency mode is and the problem that it seeks to solve. I think let's have a look at how we can do that. So I've jumped back to the end-to-end machine learning project that we did. Okay, so let's set up a high concurrency session. So all throughout this course so far, we've been using a standard session. So if we go to the Run tab and you click on this setting here called Standard Session, by default, everything is a standard session, right? Which means that one notebook uses one Spark session. We've also got this option for a new high concurrency session. So when I click on that, what's going to happen is you're telling Fabric, okay, I want to run this notebook, but I also want to run other notebooks at the same time. So it's going to start a new high concurrency session that's going to allow us to do that. You can see here, it's just starting the session. Okay, so now we can see session ready, high concurrency, right? And then if you look up here, where we had standard session before, we've got this high concurrency session and the details of it here. And it says notebooks attached, 1 of 5, right? So now we can run our machine learning training session. It can run for an hour or whatever. And at the same time, we can go into another notebook and do some other pieces of work. So now let's go back to our workspace. We can open up another notebook. Okay, so now I want to do some reading of files into the data frame. We're going back in time, back to one of the previous lessons. And what you'll notice now is because we've already got a high concurrency session running, what's going to happen is when we start this session, it's going to be a lot quicker, right? So what we're going to have to do, by default still, it will be the standard session. But if we go to the Run tab, and we click on standard session up here. Wait for this to load. We've got loading existing sessions. Okay, so there we have it. So this is our Spark ML high concurrency session. So if we click on this, then what's going to happen is we're going to be using that same Spark session that machine learning notebook is using. We run this code cell and we want to do some transformation and work in this in interactive mode. So there you go. So we can see here that the Spark session started in 9 seconds. And that's because we're in high concurrency mode. So it doesn't have to start up a brand new session. It's just tuning into that session that we've already got running on the Spark ML notebook. And so what does this actually mean? Well, if we flip back to the documentation, this gives us a lot of benefits, right? So if you're a user that's using a low capacity, like an F2 capacity of Fabric, then it's going to allow you to use a lot more resources kind of in parallel. So this is a little bit about how that works. If we flick over to the documentation, we can see that you can have multiple notebooks all hooking into this Spark session, basically. So there's a few things to bear in mind when you're wanting to do high concurrency mode in Fabric. So there's 3 sharing conditions, right? So it must be within a single user boundary, which in other words means you can only do it for yourself currently. So you can't share a session with one of your colleagues. That currently is not possible. The sessions should have the same default Lakehouse configuration, right? So both of your notebooks in this high concurrency mode should have the same default Lakehouse, okay? And the third kind of condition to allow this to work is that they should have the same Spark compute resources, right? Because you can't have a custom configuration of Spark for one notebook, maybe an XL large, an XX large configuration, node sizing for one notebook, and the other one is like a starter pool. There's a mismatch in the configurations there, so you're not going to be able to do this sharing of the Spark session. So those are the 3 conditions that we need to bear in mind. Hey everybody, and welcome back, and today we're going to be looking at how to write Scala for our Fabric notebooks, because as we mentioned previously, Scala is one of the languages that we can use to write code, data engineering, data science code, Spark code within our Microsoft Fabric notebooks. So I'm going to be looking at why you might want to do that, the advantages of doing that. We're going to be looking at how to do the basic Fabric operations like reading in files, writing to tables and things like that, all in Scala. So let's jump into it. Okay, so I wanted to start off just with some background really, and I think it's important to know that Spark itself, as an application, as open source code, is written in Scala, and that Scala code is compiled for the Java virtual machine. So these are the 2 elements that you really need to know. Spark is written in Scala and it runs on the Java virtual machine. So if you're coming from the world of Power BI and you know some SQL maybe, and the thought of learning Python is a bit more appealing to you than learning Scala, just beware that there are some trade-offs, because when we write Python in our Spark notebooks, what is actually happening there is there's a bit of translation going on. So there's a library called Py4j, which is basically the bridge between Python and Java. So whatever you write in Python, it has to translate that into something that is digestible in terms of like Java objects that Spark can understand under the hood. And that process of translation between Python and something the Java virtual machine can understand, that slows down your code. If you're a really performant data engineer, then if you go into a company with like high level of data throughput, a lot of their Spark code is going to be written in Scala. That's the language that Scala is written in, so there's no translation. That's kind of like the fastest code that you can write in Spark. The other thing to mention is because Spark is written in Scala, a lot of the new features come out in Scala first. So new functionality, updates, bug fixes, those kind of things, typically are shipped in the Scala version first, and then the pyspark version follows. These days quite quickly, to be fair. Like in the earlier versions there was a bit of a lag there, but now it's fairly keeping up with one another, so it's less of a problem now. So now we understand a little bit about Scala and the importance of Scala to Spark and the world of data engineering. Let's have a look at how we can do some basic operations in Scala. I know most of this course we've been focusing on Python because it's a bit more accessible to most people in the data space, but let's just go through a few lines of Scala just to understand how to do the basics in a notebook. Now the good news is, from the syntax that we've been learning for Python, the syntax for Scala is actually very similar, at least to do the kind of core operations that you want to do. So what I've done is I've just got 4 or 5 code cells here to do some of the basic stuff that we've been doing previously in our other videos in PySpark. So at the top, we've got a spark.read.json, and we're just reading in that JSON file, which is one of the JSON files we used previously in our course. And the only difference here is this assignment. So we have to specify that it's a val. In Python you don't need to specify, but in Scala, because Scala is a statically typed language, we need to define exactly what that variable is. So if we run this, okay, so here you go, we just displayed this df_json. I had to change the name to df_json just so that we're clear where that's coming from. And so this is the results. It's the same as our PySpark notebooks. It's exactly the same. Now, one thing that I didn't mention is you need to tell Fabric, the notebook, which language you want to use, and you can either do that at the top. So if you do that at the top, it changes the default language for that notebook. So up until this point, we've been using PySpark and Python. But if we change that to Spark Scala, that's going to change the default code cell to Scala. And you can see that in the bottom right hand corner here, we've got Spark Scala here. So that's showing you what language is being used in this code cell. So that's how to read some data from a file. We can also do some very basic reading data from our Lakehouse tables. And again, you can see that this is identical, the syntax here. So it's spark.sql. The only difference is in the assignment. And so what they've done is they've spent quite a lot of time making sure that the APIs are as similar as possible. They're not 100% identical, but if you can write PySpark these days, the Scala API, all of the code that you're going to be writing in Scala, at least the Spark code, is going to be very similar. And that's because of the DataFrame object. Again, so that unified all of the APIs and said, okay, we're going to write similar code across all different languages. So that's this here. What we've done here is just select star. So we're using SQL statements here, but within a Scala script. Select star from Spark September.property sales with a bit of a limit, and then display the results, which is what we've got here. We can also do very familiar things like df.json. Here we're just renaming some columns, and we've seen this before. So if I just run this, so now we've got df.transformed. So if I just display that, it should be the same, just with different column headers. Yeah, there you go. So you've got sale price USD like that. And in a similar method, we can use the DataFrame.write functionality. And it's exactly the same syntax. We're just writing to a delta table here. So that's succeeded. And this is this property sales Scala. So I've saved it as a table and I've called it property sales Scala. Hey everyone, welcome back. Today I've got a very useful, hopefully, tutorial about how to use MSSparkUtils. So MSSparkUtils is a collection of utility functions that help us do things like manage file systems on our Spark clusters. It helps us to manage notebooks, so there's some things for helping us programmatically run notebooks and return things from notebooks within another notebook, if that's a bit meta, but we'll get into what each of these things mean. And it also helps us deal with credentials. So how do you connect to Azure Key Vault? How do you connect to other things? And so this is going to be hopefully a very useful session. Let's dive into it. So the first thing that I want to look at is the file system part of MSSparkUtils. So if you're used to a bit of shell scripting or bash scripting, you can use this ls function that helps us It basically lists the directory, right? But if you've tried that in a Spark notebook, it's not particularly helpful because perhaps we might want to get the files from this file location. It's difficult to understand how to access that from using this kind of shell thing. So if ever you want to explore the files in your files area programmatically, you can use this MSSparkUtils. So let's dive into this. So we can start by importing from Notebook Utils, import MSSparkUtils. That's our import statement. And it's broken down into a few different sections, the ones that I mentioned previously. So file system, utils, notebook, utils, credentials, utils. And what we can do is we're going to start with the file system stuff, right? And if we call this method .help, it's going to show us what is available to us in this part of the library. So MSSparkUtils.fs.help. So these are the methods available to us. We've got CP, which is copy, and you notice a lot of these kind of direct translations from the world of bash scripting and shell. So this is going to be copy one file from one directory to another directory. Fast copy is a new functionality that's just recently come out, but it allows you to do the same, but fast, hence the name. MV is moving a file. LS is to list the contents, which is what we've just seen previously. Make a new directory. Put, which means to write some output into a file. Exists is a very important one, so we can check whether a file exists in our file's location. So this would be really good. It obviously returns a boolean, right? So if this file exists at this file path, then we can load it into a data frame, for example, would be a good way of using that. Mount is a very important one as well, because it allows us to hook into mount external data sources. So maybe you've got a ADLS container, Azure Data Lake container, or maybe even another Lakehouse files area. We can mount that into our code cell, basically, and read data from that if we have permissions. And then a few related ones to mount is unmount and mounts. So do we have any mounts? So let's just try one of those. So we've got MSSparkUtils.fs.ls. So we're going to be listing the files, and we're going to pass in kind of the directory that we want to list. So I want to list this files area, and you can see we've got lots of files here, and it's giving us the ABFS path to each file, right? So we can see there's this files.dim customer, and these are all in this adventure. Yeah, so we've got like dim customer, dim employee, dim reseller, and these are listed here, right? So it's got the name of the file, the path of the file, and the size of the file. And so you can do things like this. So if I just get the first file in that list, and then you can access properties about that file, like the name and the path and the size, like so, which might be useful or not. You can't access the modified date or anything to do with the date uploaded. So if you do want that information, it's probably best to encode that into the file name, right? So if you have a date time of when that file is written into your file's location, then you can extract it from the name here. Okay, so we can do all of these different things. I'm just going to show you the list contents today, but all of these are available to us, and perhaps in a future video I'll spend a bit more time going into each one of these. I just want to get through all of these different sections of MSSparkUtils today. So next we come on to the, let's just close these. So next we're going to come on to the notebook utilities. So we're working in a notebook, but we also have more utilities to help us manage and run different notebooks from this notebook. So again, let's do the .help method on here, just to understand what is available to us. And you can see that there's three different methods here. We've got exit, which is a method that lets you exit a notebook with a value. And that's very, very useful, right? So we can return values from a notebook using this exit functionality. Now this exit method can only be called when you're not in interactive mode. So currently we're in interactive mode, right? We're interacting with this notebook. But the exit method only works when you're running kind of a scheduled run of a notebook. So you might use this by going down a whole path of data engineering steps, and then in the final code cell you'll have MSSparkUtils.notebook.exit, and then you'll pass in that string value, and it might be a simple error message or success message or something like that that you can then handle in your data pipeline. The next one is run. So what this is going to do is it runs a notebook, right? So within a notebook cell, we can run another notebook. What this allows us to do is build some quite complex kind of parent-child type relationships within notebooks, okay? So you can have one main notebook that calls a variety of different notebooks that are embedded within them, that you call this run method to run them, and they return this exit value, right? So you can have one kind of master notebook, do this piece of data engineering, return me a value. Now do this piece of data engineering, return me a value. Now do this piece of data engineering, return me a value, and that's going to be all done within one notebook, that kind of orchestration. If we want to get even more complex, we can do that concurrently, right? So if the order of operations doesn't matter, then we can run multiple notebooks concurrently using this run multiple. So these are three really powerful tools that we can use to kind of automate and orchestrate how we run notebooks within a notebook session. So the next one we're going to be looking at is MSSparkUtils.credentials. So here we've got two methods available to us. It's the get token and get secret. So the final thing I wanted to look at was to go back to the file system section of MSSparkUtils and just show you how to do this file man. Now you can do this with Azure Data Lake Services, ADLS Gen 2, mount a container and then just use it like you would local file container in your notebook. So let's just look at that here. So if we run this piece of code here, again I'm importing MSSparkUtils from the file system library. We're going to call the method .mount. We're going to pass in the ABFS path to the Lakehouse that we want to mount to, and we're going to give it the name of the mount, which is Bronze L Lakehouse, right? So that's successfully set up. We've got the local path now, and the mount point is called Bronze LH, right? The source is here, which is what we gave it up here. This is just confirming what we've just seen there. So we've got a few different mounts. This one is the one that we've just created. And so now we can access files from this location via this local path, right? So we can just call Bronze LH, which is our mount point, and we can retrieve files and we can query files in a different lakehouse from within our notebook. Hi everyone, it's Will here, and I just wanted to record a quick video about how do we monitor our activities and what's going on in Fabric notebooks, data engineering, data science experiences. So in general, how do we monitor Spark in Microsoft Fabric? And there's a few different ways that we can do this. So today I'm going to be going through two of the different options. There's probably a lot more, but two of the main options at least, to understand what's going on, to keep track of all of your different Spark jobs, notebooks, all this good stuff. So let's dive into it. So the first place we go to monitor anything really that's going on in Fabric, including our notebooks and our Spark jobs and all of that good stuff, is in the Monitoring Hub. Now the Monitoring Hub is not specific to Spark. It sits across all of Fabric, so you can see the status of basically anything that runs in Fabric, whether it's data flow, data pipeline, a notebook, machine learning job, anything basically. So this is going to be a really good kind of first port of call for understanding, the status of different things that are running in your organization or in your workspace. And so what we can do is, you've probably seen it already, it's in the left-hand toolbar. You can click on this Monitoring Hub and we can begin to see all of the activities that are running in your tenant or everything you have access to, right? So we can see the type. the item type, the status of it. So here we've got a notebook, data pipeline run, a notebook, data pipeline run. Up here we've got some other things like dataset creation, notebooks that are currently running, all that sort of stuff. You can see the location, so the workspace, where's it living, who is it that's doing that job, so at the moment that's me, and also the start time. So we can filter this list here, and we might want to look at only things that have failed in the past. So here we're going to be looking at, okay, on this date, on 13th of September, some of these data pipelines failed, so we can have a look at these in a bit more detail maybe. You can retry it, and if you click on the detail here, you can begin to understand, you get to look at the error messages, understand where it went wrong, make sure it doesn't happen again. So that's the first thing, the monitoring hub. Now it's fairly basic. You can just get a bit of a high-level overview of what in Fabric has run in the past and what's currently running and the status of each. So another place we can go to monitor what's going on in our Spark jobs and our Spark notebooks is in the Microsoft Fabric Capacity Metrics workspace. Now, if you haven't installed this already, what you have to do is download this. It's an app on AppSource, and I'll leave a link in the description below, but it basically sets up a bit of a default data set and report, and you point it to your Fabric capacity, and you get all of these metrics available to us. And these metrics are a bit more useful than what you get in the Monitoring Hub, because it starts to give us visibility of capacity units. So we can see, okay, this data pipeline, every time it runs, it consumes 1,000 capacity units, for example. Every time I train this machine learning model, it uses 10,000 capacity units. And capacity units roughly can be translated into cost, right? So we get a really fine-grained detail into what our infrastructure is costing us. So if I just wait for this to load. Okay, so what I've done is I've told it what my capacity ID is. So here, if we just select this trial capacity that I'm currently using, then it should update these visuals to show all of my capacity metrics. Okay, so here we go. So now it's loaded in my Fabric capacity, the trial capacity that I'm using, and we've got a number of different things that we can look at to understand how many capacity units each item in our Fabric workspace or in our Fabric capacity, how much it's using up. Okay, so at the top you've got a multi-metric ribbon chart, so you can see which experiences or which items are using the most resource. So for me, a lot of it is Lakehouse operations, but probably the most useful chart is this one along the bottom. So we can see which notebooks are consuming the most capacity units, right? So for me, it's the Spark ML machine learning project, which is not very surprising. That's the most computationally expensive notebook that I'm doing, which kind of makes sense, right? Or at least in the last 30 days. And from this, you can see that it's using up 100,000 capacity units, right? So for all the time that I've been running that notebook, it's used 100,000 capacity units, which is more than half of the total capacity units that I've used in this period. So that's useful to know, right? And if you hover over, then you get a little bit more information about the duration. And we can see that it's a notebook run, and there's one user, which is me, and the duration that that notebook was running for. So that's very interesting data, because we can begin to optimize kind of our notebooks so that it's using less capacity units. Because if you're on a very limited budget, maybe you're only using F2, which is the lowest paid level of Fabric, then you don't have many capacity units to use up, right? So you have to be very efficient in how you use these capacity units, and this is how you see how to do that. So if you want to use this Fabric Capacity Metrics dashboard, then you need to go to this location here, which is in AppSource. I'll put the link in the description below. Just click on Get Now and it installs it in your Fabric tenant. Hey everyone, welcome back. And this is going to be the Final video in the series of Spark September. We've been recording quite a lot of videos. I didn't manage to do one video every day because of things got in the way, but I think we did over 25 videos in total across the 30 days of September, which is pretty good, I think. I think we've covered a lot of ground. We started off looking at the high level, like why is Spark even useful? Why should we learn Spark? Why is Spark a part of Microsoft Fabric? Then we went into the world of the Spark DataFrame and we explored across about 10 videos. What can we do with Spark DataFrames? How can we manipulate it? Got our hands dirty with some code in pyspark. Learned a lot of different ways that we can analyze data using pyspark. Some of the other things we touched upon towards the middle of the series, the middle part of the series was machine learning. So I did a long video talking you through how to do things like feature extraction, feature engineering, training a machine learning model and evaluating that model. Then in the second half of the series, we walked through more Fabric related items. So how do we manage Spark? How do we manage Spark Compute in Microsoft Fabric? How do we customize all this stuff? How do we manage and maintain Spark clusters within Microsoft Fabric? And lots of other stuff like that as well. So in this video, what I wanted to do is just highlight some of the key kind of comments and questions that I received along this journey, because I think personally it might be very useful for other people to kind of understand the answers that I gave to some of the comments that were given to previous videos. Because if one person is not sure about something that I've said, or maybe I didn't say, but they wanted further clarification on, it's likely that other people will also probably have the same question, right? So I'm going to highlight a few questions, and then towards the back end of the video, I'm going to be signposting a couple more resources that you can use if you want to learn more about Spark, continue your Spark learning journey. So let's get into it. Okay, so I'm going to start by looking at this comment here from Amrita. And this was on our video, our very early video, introducing Spark DataFrames, right? So I think that was day number 4. So we talked a lot about Spark, Spark DataFrames, Spark SQL, and a lot of the jargon can be quite confusing. I completely agree. And it has changed quite a lot as well over the last few years within the world of Spark. They've done a lot of reorganization and rebranding of lots of things. So the question here from Amrita was around clarifying what do we mean when we say SQL API and the SQL engine and the SQL component of Spark, which is completely fair because when Spark SQL is mentioned in the context of Spark, it's not actually referring to true SQL databases like relational database management systems. It's kind of just like a concept. It's just what Spark calls structured data. So columns and rows type data, as opposed to their other APIs, which are graph processing. So graph data, structured streaming, which is structured, but it's actually streaming data. So it's not batch processing as you would do in Spark SQL. The answer that I gave here was really around that Spark SQL is the generic name for the module. So when we do spark.sql, and all of our DataFrame stuff comes from this spark.sql part of Spark. And on top of that, you have the DataFrame. So the DataFrame is basically the main way that we interface with the Spark SQL API. And confusingly, we can write Python and Scala and R to interface with the Spark SQL module in Spark, right? So you've got to separate the Spark SQL bit, which is the core component of structured data in Spark, with the other languages like Python, Scala, R, that we can use to interface with that Spark SQL. So that's a really good question, and that's a really good question. And what I did was I linked to the relevant part of the documentation and all of my kind of answers to comments and queries. I generally like to link to relevant parts of the documentation in case people want to go and read a bit more about this. And in the documentation, it's quite well defined, the differences between Spark SQL, DataFrames, and also data sets, which is something that we didn't talk about much in this course. We focused on DataFrames. So that's a good place to go if you want to further your knowledge in the semantics and kind of what things are called in Spark and what they mean. Okay, so our second comment comes from Simon, and Simon asked about pandas, and I think he's been playing around with Fabric notebooks and he's been writing pandas data frames, and he wanted to know if it's better to use Spark data frames or just pandas data frames, right? Is there any positives and negatives to both? When do you use a certain one? And I think this is a really common question, right? Because lots of people might have experience using pandas in the Python world, doing kind of local development on their machine. It's going to be very common for people to come to Fabric with a bit of Python knowledge, but maybe not the Spark knowledge. So everything in this course that I've been developing over the last month focuses on Spark data frames. Now, I think what I mentioned in one of my earlier videos is that Spark is built for big data. Okay, so pandas is, or kind of like the core pandas, is not really built for very large data sets. It's quite unperformant on large data sets. It's good if you're doing some analysis on your local machine, that's absolutely fine. But when you start getting into the billions of rows and gigabytes and terabytes of data, we need to completely change the way that we think about data, and we need to change the platforms on which we manage this data, because that sort of data can't fit in the memory of one computer, right? And so when we think about which one we should be using in Fabric, it's really dependent on the size of the data, I would say. So if you're just using a very small amount of data, the amount of data you can fit in a spreadsheet, for example, a few million rows, I would say you can do on what's called single node mode. So if you just do import pandas as PD and you use, for example, pd.readcsv, you're using the core pandas library there. There's no distributed data being done. You're not reading it into a Spark data frame. And so that's absolutely fine if your data is on that scale and you can do everything that you need to do in pandas. And then maybe at the end, you can convert that pandas data frame into a Spark data frame if you want to write it to a Lakehouse table, for example. That's a completely legitimate way of working in Fabric. And it's also going to cost you a lot less, because I know if you watched the video around managing your Spark compute and setting up custom pools, I mentioned the concept of the single node mode, and that's where your maximum number of nodes will be 1. So you're not going to be you're not really going to be using Spark for the way it was intended, but that's absolutely fine. You might just want to be using Python libraries. I want to do some pandas and I want to do some matplotlib on a single node, and that's absolutely fine. Most of the content in this course has been around Spark data frames, and that's really where we have very big data, where libraries like pandas can't really support that. Now I have added in another point down here around the pandas on Spark API. So there has been some development work to retrofit the syntax of pandas to work on top of Spark and Spark data frames. And that's called the pandas on Spark API. That might not be the official name, but it's kind of what I call it. So there is options, but you don't get the full library of pandas that's available to you. So that's something to check out. Definitely, if you want to be writing pandas code, but on very large data sets, then maybe that's something to look at. But I would recommend that you just use Spark data frames. It would probably be a lot easier. And the syntax is quite similar, to be honest. So it's not going to be like you're learning something completely different. Okay, so we had this question here. Rowan Andrew, Michigan. Great series. Could you cover merge schema and overwrite schema? Yeah, so I did actually write a little code snippet here to demonstrate merge schema. So overwrite schema is similar, but just to show you how merge schema would work in the Fabric environment. So for those that are unfamiliar, merge schema basically allows us, as the name suggests, to merge two different schemas. And it works on Parquet files. I don't think you can do this on CSVs. Really, it's only really available to us when we have Parquet files. So the use case here would be when you have an employees table, for example, but you want to extend the schema. So maybe you want to add a new column, or you want to change something about the schema, and it evolves over time. And what's going to happen is all of your Parquet files for that existing schema are going to remain the same, but then all of your new files are going to conform to this different schema. Maybe you've added another column. So in that case, you're going to have Parquet files with two different schemas. So there is a way of reading in a set of Parquet files with different schemas into the same data frame. And so what I've demonstrated here is I've just got a very simple data set with employees data. And the schema for this one is ID, name, and salary. So ID, name, and salary. Then what I've got is another table, employee address, and that's got the schema of ID, city, and country. And so what I'm doing is creating a data frame of each of these. So we've got an employees data frame and a data frame employees add for the address. Then what I'm doing is I'm writing these files into Parquet format, because like I said, this only works on Parquet. And so this is just to like set up the example, just to make sure that we have Parquet files. Normally in your use case, you've probably already got Parquet files with different schemas that you want to merge. And then the only difference here is we're just going to call this Spark read option merge schema.true. So this is nothing different to how you would do this in Databricks or Azure Synapse. You know, nothing here is specific to Fabric. You know, it's the same piece of code that we would do in other tools. So if we run this, okay, so I've just run this code cell, and whereas before we had two schemas like this, we had the employee schema and the employee address schema. What this schema merge is going to do is merge the schemas. What it's going to do is combine these two schemas from two separate schemas into one schema and put all of the data aligned to this new schema. Again, a bit outside the scope of this course, but yeah, maybe in the future, because merging schemas and overwriting schemas and schema evolution in general is a very big topic in Spark. Managing schemas that drift over time is quite an important topic. So maybe that's something for a future video to go into a bit more detail there. So another question we had was around reading Azure SQL Server tables directly into Spark. So I am actually going to be doing more videos on migrating, getting data into Microsoft Fabric generally, OneLake generally. And so I'm not going to be answering this question here, but I will be answering it shortly on the channel. So there's another question around, and this came in the PySpark operations video. Is there a way to rename and delete multiple columns in one command? So I think this was alluding to the fact that in one of the lines of code that I had done with column renamed twice to change two column names, and it doesn't look great, to be honest. I'm not sure if there is an easier way of rewriting that using with column renamed, right? I think you can only do one column at a time with that specific method. There are obviously lots of ways in which we can get around this problem. So I mentioned one of them in my response. So we can treat it as a SQL command and just rename all of our columns in our SQL script. Now to do this, if you haven't already loaded your data into a file, we can do that directly using spark.sql on the source file system. Or if we've already got it into a Spark data frame, then we can save it as a temporary view and then do our SQL on top of that. There's lots of different ways. You can also use select expression, df.select expression, which another person has commented on down here. So thanks a lot for that. So yeah, there's a few different ways. Personally, I think it's cleaner just to write with column renamed twice because it's readable and people will understand what's going on. If you start transforming your data set into something completely different before you pull it back in, might lose a bit of readability there. So just something to bear in mind. So I created a video called No More Nulls, how to handle missing values in Spark DataFrames. And we had this comment here saying, nice course. Is there a way to use a more complex imputer calculation. For example, fill null values with the mean value of each agent's sales instead of the mean of the whole data set. And absolutely there's a way, there's always a way, but as far as I understand, you can't do that with out-the-box functions provided to us by the PySpark modules. Now you could very easily create that yourself, There's nothing to stop us creating our own custom imputer functions if you want to do something a bit more complex. So that's one way you could approach this, is to create your own. It wouldn't be particularly difficult. The other thing that I would mention is, obviously that's very easy to do in Pandas. So if you've used Pandas, that has that functionality out the box. So previously when I mentioned, Pandas on Spark is a thing, well, this could be a good use case for using the Pandas on Spark API, because we can do more elaborate imputation methods in Pandas. So if we can do those on Pandas on Spark, then maybe that's a good use case for that. And I've linked to this specific method, which comes from the Pandas library, which is a GroupBy fill NA, which is what the commenter here, what this guy is asking for, right? Because what we want to do is group by a specific column, like the agent column, and fill values within that class, like within that category. So to create a different imputation for each category. So that's one way that we could do that. Yeah, so there's a couple of comments on the machine learning video I did. Maybe that was not the best video for beginners, completely fair. There were a couple of comments, and I asked in that video, if people wanted me to make a kind of beginner intro to machine learning, going over some of the core concepts, like the foundational concepts of machine learning. And there was some response saying, yes, that would be good. So that's something that I definitely have planned. I'm not sure when I'll get around to that, but it would be really good to do that as well. Because I think a lot of people, if you're coming from Power BI or SQL world, now you've got all of these machine learning AI tools available to you. You might want to learn how to get the most out of that, right? How do we use these things? So, but you do need a bit of basic knowledge about some of the key concepts. So that's something I might be adding in the future. What happened today, 17, 19? Yeah, sorry. I took a bit of a break for days 17 and 19. There was lots of things going on in my life, but all of the content, or nearly all of the content that we agreed on the first day in the schedule, I provided videos for. Some of them are merged into one video, right? So whereas before in the schedule, I might have split a topic into two or three videos. In the end, I merged some of them into one video. This is a good example, the customizing Fabric runtime video. So I talked a lot about custom pools, Fabric compute, Fabric runtime, all in one video, because I think it makes sense to tackle that all as one video. So I took a few days off and created one longer video. So that's what happened there. Running into a problem loading multiple CSVs into a Lakehouse. Yeah, so this is not really related to the video. It's just a general question that this person had. It was around CSV files with different structures, and how do we read them in when the number of columns sometimes changes. So there is a way that we can do this, and we can make use of a specific piece of functionality within Spark. It has kind of lazy loading, so it understands the structure of your files, okay? So here you've got, and then what that means is you can run SQL directly on the files. So here, what you can see is you've got, I'm not sure if you can do this on CSV actually, but you can definitely do it on Parquet files. So you can select statement in your import statement from a file, if you get what I mean. So you don't have to select star. You can do select column 1, column 3, and column 5, for example, from the file. And so what that means is If those 3 columns exist in your file, then bring them in. And then the structure of the file doesn't matter so much because you're being explicit in your select statement. So that was something to bear in mind there. And that was it. So those are all the comments that we got throughout the course. If you've got any more, of course, I'm always happy to answer any more questions. Just leave them underneath this video and I'll type out the answers to you there. There is one more thing that I wanted to point to before we wrap up. I did mention that I would give some pointers to resources that you can use to kind of continue your Fabric and Spark learning journeys. And probably the best resource that I've come across is the Fabric Espresso playlist in YouTube as well. So it's created by people in Microsoft. It's part of the Azure Synapse Analytics channel. And you get very regular content that goes into deep dives into some elements of Spark, data engineering, data science within Microsoft Fabric, right? And the good thing is that it's presented by people in Microsoft, right? So they know the tools, they probably created the tools, they know how to use them better than anyone. And so you get some really good insights about how to use these tools better. And they're quite regular, right? Yeah, so this is a book that's on Databricks, or Databricks provide it for free, basically. Learning Spark, lightning fast data analytics. And this is a really good book. And you can see it's completely free. I didn't actually know it was free. I bought this, but anyway. Or maybe it wasn't free when I bought it, but this one is a really good overview, although it's kind of presented by Databricks. The concepts of Spark is the same across any platforms, basically. And if I just show you what the overview here is. So an introduction to Spark, the downloading it. You won't have to download it because you'll have it in Fabric, assuming you're going to be using it in Fabric rather than downloading your own local version. All about Spark structured APIs. So the DataFrame, we talked a lot about that in our course. Spark SQL and the DataFrame in more detail. Spark SQL interacting with external data sets. So there's your SQL Server there. Optimizing and tuning Spark applications. So some of these we talked about, but there's lots more to learn there. Structured streaming is something I didn't touch on at all in this course. That's kind of a whole nother world. But definitely going to be looking into that in more detail shortly on the channel. Building data lakes, machine learning, all this good stuff. Lots to go through there and some other stuff. So yeah, I'd really recommend this book. It's got all of the basics and more than the basics really. It's got very good coverage of basics, foundations, intermediate stuff, and also some advanced stuff as well. So would definitely recommend that. Would recommend this channel. And yeah, I'm sure there's lots of other YouTube channels as well. So, you know, if you found any resources that are useful for learning Spark yourself, then leave them in a comment and hopefully other people can get value from that as well. That's it for this series. It's been an awesome 30 days. We've covered a lot of ground. I hope you found it valuable and you've learned something new. If you did, then I'd be grateful if you can share this playlist. I'll leave a link to the playlist that you can share with anyone else, perhaps other people that are making the journey into Spark, into Fabric, that maybe haven't had exposure to it before. And yeah, hopefully you've learned something new. There'll be a lot more content coming on this channel. I'll be diving into a lot of end-to-end projects in the future. We'll be looking at SQL, as in T-SQL, not Spark SQL, transactional SQL, KQL as well. We'll be going into all of the different experiences in a lot more detail in the future. So if you're not already, then you should be subscribed. And thank you very much for watching this series, and I'll see you in the next video.